Hello, everyone, and welcome to day 2 of the Red Team Village at GrayHat conference. Today I have with me my co-host, Omar Santos. Omar, what are you really excited about today?
I'm very excited about several, briefings that we have here today, and we're amazed. I'm very honored to have, such a, lineup of speakers from all over the world. We have folks from Argentina, like Mauro Eldridge and Santiago Perez. They actually are talking about malicious learning and how, they can, the bad guys are actually generating fake news and political propaganda using machine learning. So they're going to go in detail and do a few demonstrations as well. Pablo Artuso and Ivan. Ivan is actually from France. Pablo is actually in the Americas. They're actually talking about unauthenticated access to SAP applications, right? And they're going to walk through, several scenarios that they have gone through. Arsenio Aguirre, he's actually talking about offensive Docker, and for both CTF and also for pen testing and bug bounties. And as a matter of fact, in somewhat similar, yesterday you saw a presentation by Rohit that was releasing a tool called Docker Ent, which is actually to do assessments in Docker environments, and is one of the first tools that you can do a runtime assessment in the Docker container versus static analysis, right? And another one that I'm looking forward today is Brent White's and Tim Roberts breaking into your building, a hacker's guide to unauthorized physical access. So they're, shifting gears into more of a physical security type of talks. And also our friend Cedric, right? So Cedric Owens is doing a mix between blue and red team the considerations in modern tech environments. And as a matter of fact, I was talking to him earlier this week, and he has a really amazing presentation here for us today. And Felipe Pires, he's actually from Brazil. So another international presenter, and he's talking about pivoting and exploitation in Docker environments as well. So a lot of Docker type of talks, a lot of DevOps type of information in here as well. So very excited about it.
Yeah, it's a great mix of topics. All the cloud technologies mentioned, stuff related to bug bounty, SAP. I really can't recall the last time I heard anything about SAP in environments. One of my past jobs, we were getting ready to have a SAP pen test. So it's a great coverage. And as you said, all these international speakers, I mean, this is, at the levels of some of the top conferences. So I'm really, really excited about the second day. And don't forget about the CTFs. The CTFs are going. If you hadn't started, join in on those and make sure to plug in on Discord and talk to the people. We may all be socially isolated, but that doesn't keep us from communicating digitally.
Absolutely. And the information about how to join the conversation in Discord is in the bottom of the screen. And without any further ado, hope you enjoy the conference. Let's get started. Welcome back. Our next presenters are Pablo Artuso and Ivan Gerner. Their talk is titled Unauthenticated Access to SAP SolMan, Root Them All. Thank you so much for both of you, Pablo and Ivan, for supporting the Red Team Village and for supporting a GrayHat. We look forward to your presentation and take it away.
Hello, everybody. Thank you for joining us in this presentation. In the talk of today, we're going to speak about the chain of vulnerabilities that we discovered a couple of months ago that will or may end up allowing unauthenticated attackers to get root access to every server part of your SAP infrastructure. So hope you enjoy our presentation. First of all, I would like to introduce us. We are Pablo Artuso and Evan Januer. We both work at Onapsis. Being part of the security research team means that we are mostly devoted to projects related with vulnerability research, and when the time comes, we are also the ones that perform penetration testing. This is our agenda for today. First, we're going to start with a brief introduction. Then we're going to have a brief chapter talking about the different findings and the details of each finding. The third chapter will be a chapter that we are going to share an experience that we face as a customer. And the fourth will be just some conclusions to end with the presentation. So let's start with the introduction. Why SAP? So SAP is one of the largest companies when it comes to developing software. In particular, SAP is devoted to business solutions, but these kind of business solutions are used by almost every mid to large company in the world. Also, these kind of solutions are protecting one of the most important data of the companies, like financial records or records related with employees of the company. So combining these two things is which makes, from my personal point of view, SAP really, really important and interesting target from both point of view. For the point of view that attackers want to access it, and also for the defenders to try to protect the data. This is an infrastructure that we're going to use as an example for the rest of the talk. We are going to keep coming back to this infrastructure when we are going to explain a new vulnerability. So it's important to have it clearly how this infrastructure is built. And so I'm going to explain it right now. We will have here, as you can see, 3 different servers. Each of these servers is running some particular OS and some particular SAP application. The reason why we have such a diverse setup is because we want to stress in this talk that the vulnerability that we're going to show you today will affect your SAP implementation and your SAP servers, no matter which OS are they running, no matter which SAP application are they running. And also, as any other SAP infrastructure in the world, there's going to be another component part of this infrastructure, which is the SAP Solution Manager. And I will let Ivan talk more in depth about this component.
Thank you, Partu. Hello, everyone. My name is Ivan, and I will continue to speak about SAP Solution Manager. What is a SAP Solution Manager? It's what we call a technical SAP system because there are no business data into it, but this is kind of system only used by SAP administrator to manage whole other SAP system. So we can represent it like that. SAP administrator connect only to this one to perform some administrator tasks to all other one. And it's very useful for SAP administrator because it's OS independent, database independent, and also a version independent. So you can use the SAP Solution Manager to perform administrator tasks everywhere. So you understand that SAP Solution Manager, it's highly connected with high privilege on whole other SAP system. So why we took a look on it? You can compare the SAP Solution Manager to a domain controller in Microsoft World. So if an attacker compromises the SAP Solution Manager or have a full access on the SAP Solution Manager, this is completely a game over for the landscape. It can jump to all other systems and do what he wants. So basically, we think this is a technical hurdle of the SAP landscape. So this is why we decide to jump on it. The first thing we need to introduce is what is called SMD agent. So to be efficient, the SAP Solution Manager use a little component. This component is the SMD agent. It's installed in whole system you want to manage. So it's very useful because it's OS independent. It's work with Windows, Linux, and work with all database support by SAP, etc. So you can represent it like that in the picture. So the SAP Solution Manager basically used the SMD agent to communicate with the system they want to manage. So the SMD agent can perform some diagnostic stuff, monitor the system, etc., etc. And behind the SMD agent, this component, these services run under one user, the DAA ADM user. So this is a little user without a lot of privileges, but so this is normal things. All right. One last thing, it's the SAP Solution Manager is what we call a dual stack in SAP world. So basically, you can connect using a SAP GUI, the normal SAP user interfaces, but also you can use directly a web browser, because there are web services hosted by the SAP Solution Manager. This is important because basically this is where we start. So yeah. So let's jump to what we find and how we find interesting stuff. So we separate in three steps. So the first one, it's how we find unauthenticated access to the SAP Solution Manager. And so let's jump on this first step. So the big the first question, the big question when we start for this kind of a huge system, it's where to start, because the SAP Solution Manager, it's a SAP NetWeaver with a lot of services, a lot of web services, etc., etc. So we decide to focus our research on the communication between the SMD agent and the SAP Solution Manager, and to look for web services involved in this communication. So we take a look on the SAP Solution Manager, and we find around 60 applications with SMD agent, etc., etc. in the name. And in all these 60, we figure out that there are 20 accessible through HTTP request, GET, POST, so something like that. So this is a sample of what we find. So basically, this is a web services exposed by the SAP Solution Manager, and we start looking on all of them. And very quickly, we find several little vulnerability like this one. This is a blind external entity on these services. Also, part 2 found this one on the SVG convert. So he found a way to download image, but also to perform a denial of services by a CPU consummation. And also, I found this little one. Basically, we found a way without authentication to grep on files. So it could be efficient if you want to retrieve the configuration file, for example, etc., etc. The feeling behind this three little vulnerability, it's we find it very quickly. Like, I don't exactly remember, but it's few days. So it convinces us that we need to go deeper on this area, because we find all these several little vulnerability very quickly. So it's like a feeling. It's like a feeling. Okay, we need to go deeper. We expect something more. And eventually, I found this web services, and this is the real story. I find the web services, and I provide the URL to part 2 and say, hey, look what I found. It's appears very, very interesting with very powerful method, but unfortunately, everything is authenticating. And part 2 answered me back very quickly, no, it's not. And yeah, I double check, and he's right. There are no authentications. I fail when I test the authentication stuff, and so we get this web services without authentication, and a very interesting one. So I'll let part 2 explain what we found exactly here.
So the EEM application was a really interesting application. It basically allows SAP administrator to create scripts that will mimic user actions. These scripts will be uploaded to the EEM application, but then are going to be deployed to an entity that are called EEM robots, which are the guys that are gonna finally execute those scripts. One thing there is that SMD agents, these agents that Ivan was talking about, could act as EM robots by default. So if you have, I don't know, 3 or 4 SMD agents connected to your solution manager, this means that you have 3 or 4 EM robots, at least. The final goal of this application is to have early detection of issues. So instead of having a actual user face an issue, if you could build a script that will mimic the action that a user is supposed to do, if that script fails, you will get a notification before an actual user faces. This is first a more graphical way. The first step is an SAP administrator creating a script and uploading it to the solution manager, and the second step when it gets deployed. But if you recall what Ivan was telling you, this EM application was exposed without authentication. So our first question was, okay, this means that maybe an attacker will be able to do the same thing as the SAP administrators. So in order to answer that question, we should and we needed to do a more in-depth analysis of the application. And with the goal of exploiting this and analyzing this application, we divided our whole idea in 3 different phases. The first step will be to try to understand how we can upload and how we can execute different scripts. Once we know that, we need to understand how we can build our own custom scripts. And once we understand that, we can start analyzing how we can make to abuse those scripts and probably perform some attacks like, I don't know, having a remote code execution. So let's begin with the first step, with the first phase, how we can upload and execute scripts. In order to answer that, we need to do a more in-depth analysis of how this EM service works. It basically is a sub-service which exposes a lot of different methods, but we're going to talk about 4 of all those methods. The first important method was run script, which, as the name suggests, will allow you to execute a particular script. The second method is the get agent info that will retrieve a lot of different information from all the EM robots that are connected to your solution manager. The third step is a save agent properties. This method will allow you to modify particular properties from the EM robot that you choose. And the final method will be upload resource, which will allow you to, again, to upload a file or a script to your EM application. So in order to execute and to start playing with this, what we did first was to choose a particular EM robot, part, of course, of this whole infrastructure. And the first method that we executed was run script. But unfortunately and surprisingly, the error message that we received was, hey, the EM is not activated. So we needed to find a way to turn it on. Our second step was to execute get all agent info, that we retrieve a lot of different information from all the robots that were part of their infrastructure. There, we detect that there was a property that was called EM enable that was set to false. So using the save agent property, the other method, we modify that in our chosen EM robot, and we set it to true. Once after doing that, we execute again get all agent info, and this time we confirm that the change was made, and our side step was to run again the script, a random script. And this time we receive a very interesting message. It will say, hey, the full script, the name that you proposed, was not an actual and a valid script. This means that we were able to run scripts. But anyways, we needed to understand how we can upload a new script. So we start playing with the 4 method was upload resource. We first tried to upload resource, and this upload resource was receiving a parameter that was the content of this resource. We put some string there, some random string, and we receive a message that is really common. It's another really common mention or exposed by XML parsers. That was saying, hey, I was expecting an XML file and you didn't provide me that. So our last step was to try to provide an XML prologue, and the error message was, hey, yes, I recognize this as XML, but some content is missing. So at this point, we knew how to upload and how to execute different scripts. So let's go to the phase 2. That was basically how can we build our custom scripts. We start reading documentation. We start reading that there was an EM editor that was allowing you to create these different scripts. But unluckily at that time we couldn't use it. But then we realized that HTTP provides by default an example of an HTTP script. So by grabbing that example and start modifying and play a little bit with the error messages that were really, really verbose, we end up having being able to create a script that was basically performing an SSRS attack. So we were able to create whatever HTTP script we wanted. And therefore, yeah, exploiting an SSRS, server-side request forgery. So this was really good. It was a way to show the impact of having this application exposed without any kind of authentication. So step 2 was done. So now there was important time, a really good time to understand how we can abuse this feature that we had, that we could build our own script. So let's start with phase 3. So as you remember, yeah, we have an SSRS that was interesting, but we were dealing with an application, again, an application, a web service that was allowing you to build scripts, and in particular HTTP scripts. So having an SSRS is nothing surprising, right? So we wanted to go forward further and get something else from there. At this point, we shift from a black box testing to a white box testing, and we start analyzing the application because it was a Java application more in depth. We went to the grammar of the scripting language, and we understood that it was a message-based language, and basically the different types of the message was command. So from my personal point of view, every time that I see something that is called command, I go behind that because most of the time it's something interesting. Besides it, once we found this was a message type command, we went also to the parser and we understand what was this parser doing when it received something that was a message type command. And we saw that was executing some command, the command that was being provided by parameter inside the script. And all these commands were part of the whitelist. The only commands that were able to be executed were part of the whitelist that was defined in a kind of extension. At that point, we didn't know what was an extension, but we just throw a grep in the directory where the Java application was implemented, and we found a very interesting file that was showing all the different commands that were able to be executed, and also the classes, the Java classes that were implemented. So this was a really, really good resource to start understanding the different commands we have that were basically available to be executed. So now we have a list of 12 more or less commands that were able to be executed. And we start analyzing, okay, now that we have the different commands, what we can do with each of them. Can we maybe find a vulnerability inside of them? So we start trying with each of them, trying to understand what were they doing. And finally, we got one that was basically vulnerable to a remote code execution. We believe that something like the thing that is shown in the snippet was happening. That was basically this command was interpreting or evaluating JavaScript code and was actually executed. But the JavaScript code that you can execute it was provided by directly inside the script, without any kind of monetization. And it was important, and script engine, as you can see in the snippet, that is a really common bug in Java applications that were using this engine without any kind of monetization. But if you recall of this, who were the ones able to access, to perform scripts and to create and to build scripts? If you remember that, as we said that this application was not asking for authentication, every person was able to create and build scripts. And the second interesting thing about this is that, if you remember, this application is part of the EM robots, and the SMD agents are by default EM robots. So this means that this application, or in fact, the piece of the JS code that is being evaluated is actually being executed by the OS user that is running inside the SMB agent, which is the user DDADM, right? So this means that anybody or everyone could or can execute commands as the DADM user. So this was a really huge finding, and it was the composition of the phase 3 that may basically allow us to have a remote chain, a full chain of exploitation. So how that attack summary will work? First of all, the attacker will get all the agent info of all the EM robots, will choose the target, will modify if in case the EM is turned off, it will turn it on, and finally we'll upload the remote code execution script, and we'll after a couple of minutes will be executed those scripts. So here we have a quick demo. On the right side of the screen, you will see the attacker screen, which is pointing to the solution manager of the company. And as you can see there, we have 4 different agents. All these agents are, we have 4 agents which are the same as you remember we explained in the implementation, the example implementation. We have 4 different servers. This is the same thing. And then as you can see on the left, every shell will start popping up from the different SAP agents that are connecting to the solution manager. As you can see, the first 3 are shells from a Linux system, but if you pay attention to the last one, that will be a Windows shell. So again, we are stressing here, there's no difference between OS. This attack will still work. So finally, as a conclusion here, to close this part, this means that an attacker without providing authentication will be able to execute remote code as VAADM, which is the OS user that is running inside the SMB agent. And I will let Ivan continue with the chain of vulnerabilities now.
All right, so let's jump to the third part of this research finding. Basically, how we route them all. To understand this part, we need to introduce a new agent again. The name is SAP Host Agent. So the SAP Host Agent, it's again a little component. It's present on every SAP installation, and it's here to help administrator to perform a lot of things, not only administration tasks like monitoring, start and stop the instances, etc., prepare for upgrade, prepare for installation, kernel upgrade, etc., etc. So this is very powerful agent, and again, this is OS and database independent. So interesting. Why we decide to look on this particular components? For 3 reasons. The first one is a couple of services run as root. So this is always a good thing to look on this kind of services. The second thing is we found that there are 1 port open on this component, the 1128. Okay, and the last one, and probably the most important one, is we find that our user, the DAADM, the user we are able to execute command from the SAP Solution Manager, is listed in the configuration file. And in this configuration file, it's listed into the parameter named service admin user. And it means what? We look at the documentation very quickly, and it means that this parameter lists the user, the local user, able to communicate with this SAP Host Agent. So, okay, everything green light, a lot of green light, so let's jump. So the next step is to how from this SMD agent user DAADM access we can perform or call for to do something with SAP Host Agent. All right. Normally, locally, the administrator use the binary in the SAP kernel provided by SAP, the SAP host control, to perform some to call for function provided by the SAP host agent. So this is it's appeared to be very simple binary, and the list of the function is huge. When we call about function, we speak about all these function. This is a lot of functions, a lot of already powerful function. This is all what we can do with the SAP Host Agent. All right. So we start to try to understand how it works. We try to perform some tests, and we figure out that when we call the SAP Host control binary and we call for a function, behind the binary perform basically a lot of requests locally on the local host on the 112 port, and all these requests is it's like web services and SOAP requests. So okay, we find a lot of web services exposed, etc., etc. So okay, the first issue we get, it's even if you are logged as DADM on the system, if you call for a request to the SAP Host Agent to perform something, he asks for the DADM password again. No, not again, but he asks for the DADM password, even if you are logged as DADM. So it could be okay in a normal case, but in our case, we execute command from the SAP Solution Manager, and of course, we haven't the DADM password. So we begin to analyze the binary, and we figure out there are one feature called trusted internal connection. And what this kind of feature allow, it's to, even if you haven't the password, you can request a temporary password. Like, so you call for request logon file. This is a web service as exposed by the SAP Host Agent. The SAP Host Agent send back a path to a file, for example, logon32. And locally, the user read the content of this file, and the content of this file, it's a temporary password. So the list of the number is a temporary password you can use one time to perform to request a function. So it's not very complicated, but everything is local. You can't perform it. You can't do it remotely. The request logon file is only accessible locally. But it means what? It means now without providing any password, you can call a SAP Host Agent function. So now from the SMD agent, you can communicate and do something on the SAP Host Agent. When we speak about call function, we speak about call all these functions. There are a lot of functions. They are already very dangerous functions. Like you can stop the instances, stop the database, change the IP address. Don't do that at home. We test it, and it's not good for the system. You can do a lot of things. So what we would like, it's we would like to find if there are a way to basically execute command as root, because behind all these function, 99% of this function it's executed as root with very high privilege, root for Unix and system for Windows. So let's speak about this function, for example, the execute operation. The execute operation, it's a function you can call to the SMD agent, to the SAP Host Agent, sorry, and you can call for different operations like the ping the SAP Host Agent, get some OS information, get the version or something like that. And we found out that one of these operations is vulnerable to a past traversal, and with this, by exploiting this vulnerability, you can force the SMD, the SAP Host Agent to execute SAP Host exit. The hard-coded ./SAP Host exit is executed, but you can execute it in your own directory, in the directory owned by DADM. So it means what? It means you can force the SAP Host Agent to execute your SAP Host exit malicious binary, and you can execute every command as root. So, all right. We find it. Also, we found another one for execute installation procedure. This function is here normally to start the SAP installation. So, for installing SAP, you use a binary named SAPinst. And again, we find a way to trick the function and to change the sources of the SAPinst, to change where is the Sapiens binary. So it means what? It means if you expose this kind of vulnerability, the SAP host the support agent as root execute all this command, and the last one, as you can see, it can execute sapiens but from arbitrary directory. And of course, in this case, the sapiens is not the real sapiens; it's a reverse shell, and we get a shell as root like that. Another one, it's for this one. So this one again, it's we don't exactly understand what is the purpose of this one, but we figure out that you can prepare the system for an upgrade or for installation. It's just what you can do before launch for the installation. So with this one, you can mount, unmount, etc., etc. And when he tried to mount the file system, he mounts with root privileges, so it's very dependent of what you put in the file system. And what we understand that it's possible. So attacker prepare a malicious file system, for example, with only one file with a shell, and with the owner of this real shell is root, and the privilege is basically 4777, and transfer. Upload this file system to the target and use this function RCOS prepare to mount the file system, and the file system is mounted with root privilege. So again, we get a reverse shell like that. The last one we would like to share is, for example, this one. So deploy managed object from SAR. This is not the most simple function name. So this one is here normally to help to decompress a SAR file. A SAR file is basically an archive, a custom archive provided by SAP. So if you want to upgrade the kernel, for example, you download the SAR file from SAP website, and you can decompress using this function. This function check if the archive provided it's a SAP signed archive. So you can't create a malicious archive and ask to decompress it. We performed some tests, and we figured out it's not possible to overwrite file or to overwrite directory. So we find very little things. It's using this function, you can create directory everywhere, because, for example, if you want to write a directory in the home directory of the SAP Host Agent, for example, in /user SAP host control, normally DADM haven't the right to do that, but using this function, you can create a directory because you ask for uncompressed archive into this directory. And before uncompressed archive, the SAP Host Agent creates the directory, of course. So at the end, using this function, you can create every directory everywhere. And for example, you can create a directory in /user SAP host control. All right, like that, it looks like useless. You are right, but if you couple with another feature provided by the SAP Host Agent, it could be very useful. You will see. So there are one feature. It's named the SAP Host Agent have a self-upgrade process. It means what? It means the SAP Host Agent can upgrade this kernel automatically itself. And to do that, this is enabled by default, and what we understand about this process is every 5 minutes, the agent itself check if the directory /user /SAP /host control /new exists. If this directory exists, he performs an authenticity check into it. So basically, he calculates hashes, he counts the number of files, if the file have the good name, etc., etc. If one is missing, one verification fail, or whatever, he just stop. And if everything appears okay, he executes the SAP Host Agent execute as root the SAP Host exec binary into this new directory. So the new SAP Host exec and minus upgrade to upgrade itself. All right, so we analyzed deeply the binary involved in this automaticity check, and we figure out that if you create a particular file named .force, it disables the authenticity check. So basically, it forces to install the kernel. So it means what? It means if we back to the process, it means that every 5 minutes the SAP Host Agent try to execute SAP Host Agent. That's it. And so if you remember, we can create you can create a directory in SAP Host exec in a home directory on SAP Host Agent using the previous function, the function to decompress archive. So what kind of directory we can create? We can create a directory new. We decompress a valid archive, like whatever, and because this new directory is owned by DA ADM, now we can create a malicious SAP Host exec, SAP Host exec, and execute arbitrary root command like that. Every 5 minutes, we need to wait 5 minutes. So you understand, we find several ways to execute command as root or system using this several little vulnerability in this post. So one demo. So this is exactly the same display of the previous demo, but this time instead of just execute command as DADM, we try to exploit one vulnerability of the SAP Host Agent to get directly a root shell. So the vulnerability we exploit in this example, it's one related to the SAP Inst, and as you can see, so on the right, this is the attacker point of view, and on the left, this is the pop-up, a shell pop-up, a root shell provided by the target system, and this is very quickly, very reliable, and very efficient. And so we have root access on whole SAP system, Linux, the SAP Solution Manager itself, and also the Windows one. So and everything worked very quickly and very well because the SAP Host Agent it's OS independent. So now I'll let Patu explain a real case scenario we figure out.
So the following chapter is an actual exploitation of this vulnerability in a customer. In order to give you more context, the customer's solution manager was vulnerable to the EEM vulnerability. This means that we, as a penetration testers, we have a blindly monitored execution that could leverage to gain further access. However, we have some limitations. The first limitation was that all the reverse connections were being blocked by a firewall, and the second limitation was that due to the nature of the exploitation of this bug, there were some characters that were not being able to be used in the command we want to execute. The only special characters that were being able to be used were the ones that are listed on the bottom of the slide. So we have a really interesting challenge here. We need to bypass these limitations in order to at least being able to read files that were part of the operating system of the files that were affected, of the server that was affected. I really like this kind of finishes because it's something that you have to do quickly and you don't expect, and well, you have to develop yourself quickly there. But the problem was that we have only 2 days. We were 2 days before ending the project, so I needed some help to develop and to think an idea really quickly. So I sent a message to a teammate and friend also that is part of the team, which is Ignacio Fauro. And basically, all the following slides are the result of working together into this problem. So we need to find a way to read files, but we thought that maybe if we are able to write files, then we are going to be able to have a full remote code execution, which is something bigger, right, than only being able to read files. However, it was not possible to use write directions nor pipes. So it was at least something tricky to being able to write files, right? And after thinking for a while, we realized there was a command installed by default in every Unix system that may help, which was DB. So for those who are maybe not aware about this command, it's a really interesting command that allows you to copy bytes from a source point input to an output input, to an output basically, right? But the cool thing about it is that you can move within the file or the input file. And let's say, for example, that you want to copy only the third byte of a file and copy it to a, I don't know, second byte of another file, you can do that. So leveraging that feature, what we thought was maybe we can start copying from different and multiple input source files, different characters, and write all of them to a particular output file. And basically by doing this, we are going to be writing any file that we want with the content that we want. So we can write a bash script and later execute it. So this is an actual example of how to do that. On the left side, we have the command that we want to execute, ps redirection A. Remember, if we want to use the exploit for the EM, we are not going to be able to use this command, to run this command, because it has a redirection. And also, as you can see there, we are assuming that we have and we know the content of those files, the file 1.xml and the file 2.log. So for now, this is an assumption, and we are going to speak more about that in the following slide. So if we know this and we have this, what we can do is first we can execute a dd command that will grab only the character p from one of these two files, in particular from the file 2.log. Again, we need to know the existence of this file and its contents. So afterwards, we can do the same with the S. We can do the same with the redirection, and we finally can do the same with the A. All these dd commands, we are gonna be writing the output to a file that in this case we chose to call rest.sh. So after executing all these dd steps, we're gonna see finally a file called rest.sh with the command that we want to execute. So up to here, we have a win. This means that we can write files, but we made a very important and huge assumption. That is that we know the content and the existence of those files. I would like to call those files like anchor files. And the big question we had is, okay, where can we get those anchor files? How we can be sure that they exist and that we know its content? First, we thought that maybe we can base on anchor files that are all the time present in the operating system related with the version and whatever. But that was a little bit difficult because, again, maybe a change in the version of the operating system will change everything, and it was a little bit difficult. Then we realized that Python was being able to execute. I mean, we could execute Python in a vulnerable server. So what we did was we set up an HTTP server by executing the module simple HTTP server from Python, and we realized that Python server, or that command, was being executed in a particular working directory that was full of TXT files. So if we create there, or if we execute an HTTP server there, those files are going to be served, and we have a lot of different anchor files that can be used. So leveraging these leveraging these two things, I mean, the way we can grab anchor files and the way we can write files, what we can do is have a complete bypass. The bypass will work. I will explain right now the bypass. On the left side of the slide, you will see the pentesting box. On the right, the vulnerability mediation, and at the bottom, you will see the remote code execution that is being actually executed. So the first step will be, okay, we set up an HTTP server. As you can see on the bottom, every special character that is going through, I mean, the remote command has all allowed characters, right? The second step will be to download all the anchor files that were served by the HTTP server, so there is not a command that is going to be executed remotely. The third step will be to do what we did with the DD steps, right? But we use a tool that we developed that is called DD encoder that will grab the command you want to execute, the different anchor files, and we basically output the list of DD steps you have to execute in order to have that command written into a file. The fourth step will be execute each of those DD steps in order to finally create that output file which is called rest.sh. And the final step will be, okay, now let's execute that script, and we are going to have a full remote code execution. Here we have a quick demo of how this works. First of all, we're going to use the script of the exploit for the EM, which we call announce remote code execution, blah, blah. And here we are executing the command that we turn on the HTTP server in the Python. Then afterwards, we are going to show you that the PS redirectionary won't work, again, because that chart is always blocked. On the bottom pane, what we're going to see is that we are going to issue a command that will grab all those anchor files. And while that is running, I'm going to show you that the DD encoder is a really easy Python script, and it's easy also to be used. We need to provide the anchor path, the folder where all the anchor files are present, which is the thing that we're going to download from the vulnerability examination, the command, and the final or the output script that we're going to create in the vulnerability server. The output will be the DD steps. Then I'm going to see here, you're going to see just that some trick in order to bash scripting and start executing all those DD steps in the vulnerability examination. So after a couple of seconds, you will see that the final script was created in the vulnerable server, and then it's a matter of executing that script in order to have the full remote code execution. As you can see here, we're going to execute those scripts, and after executing, what you should see is a new file created, which is we have named A with the output of the PS. So this was a really interesting trick that we had to use and create in a penetration test. I hope you enjoyed. And now I will let Ion continue with the presentation in order to close it.
So as a quick conclusion, we would like to share some things. The first one is we would like to sum up the attack. So remotely, without authentication, an attacker can access to the SAP Solution Manager, execute command on every SAP host to connect it to this SAP Solution Manager, and by exploiting some vulnerability on the SAP Host Agent, it can leverage to root access or system access. So this is a very, very important attack, and the risk behind it's huge. So the post-exploitation, it's all over espionage, fraud, and sabotage. So you can leak everything, change what you want, and of course you can crash the system remotely and hold the system. So this is very important. We would like to provide the patches involved in this talk. So this is a list of SAP security notes. SAP security note is the patches, and also we provide another SAP security note. This is not the vulnerability we cover today, but this is also a part of our research, and there are some very, very important vulnerability correct in this SAP note against the SAP Solution Manager. So take a look on them too. So to answer the question if you are vulnerable or not, there are no miracle. You need to check the version. So if you are under this version for SAP Solution Manager or under this version for SAP Host Agent, you are at risk. So there are not a lot of recommendations. The most important one is to keep up to date the SAP Solution Manager and the SAP Host Agent. The SAP Solution Manager is very powerful system. We know that SAP administrator like the SAP Solution Manager, that they use it. So put it in the middle of your security scope, and very, very important system. You can find all references of the security patch, and also thank you to ONAPSIS Security Lab. Without you, nothing was possible. So thank you, and also thank you to SAP security team. We work a lot with them the last past years, and it was very, very efficient. So thank you everyone, and we wait for your question for sure. Thank you.
Welcome back. The next presenters are Mauro Eldridge and Santiago Perez. Their talk is about how to generate fake news and political propaganda using machine learning. Thank you so much, Mauro, and also for Santiago for supporting the Red Team Village and supporting GrayHat. The floor is yours. Take it away.
Welcome to our talk, Malicious Learning, Generating Fake News with Machine Learning, by Mauro Eldridge and Santiago Perez from DC 5411. Before we start, I would like to introduce myself, and then my partner Santiago will introduce himself and give a brief introduction to this talk in general. My name is Mauro Eldridge. I'm an Argentine hacker. I'm the founder of the VCA and DC 5411, Argentina and Uruguay. I spoke at many conferences around the world, including the USA, Russia, Brazil, Colombia, Iran, India, United Kingdom, and Pakistan. Now my partner Santiago is going to introduce himself.
Hello everyone, I'm Santiago Pérez Montaño, better known as Cypher. I'm currently an Army officer in Uruguay. I work as an engineer at BCA, and I am also a member of DC 5411. I have the opportunity to give a conference at Autodefensa Digital at Argentina, and today on GrayHat. I hope you enjoy our talk today. Our main objective in this conference is to tell you in detail how we managed to create a framework that had the possibility of creating fake news and propaganda generator, thereby demonstrating that it really works and is operational at this moment. In the same way, we are going to give a brief explanation of how it's composed and what was used to create it in such a way that it is understood at all levels to avoid lack of concept. Also explaining the Markov chains, what was used at the basis of said framework. In this image, we can see an example of how Big Brother generated 10 false news based on Markov chains, generating greater accuracy due to having advanced artificial intelligence in its source code. In this disclaimer, we want to clarify that all the technology used depends on the input that we enter, that there are no intentions to attack religions, beliefs, or political ideas, much less people and ethnic groups. Big Brother is a fake news generator which can be designed in which to lean. In this case, left or right is conditioned by the content that is fed into our tool, and there are no pre-programmed biases within the system. This talk is for fun and for waiting to improve ourselves as researchers and developers. It does not have any political or criminal purpose. We appreciate being able to maintain that nature throughout it, and especially in the question section. Next, I will make an introduction about artificial intelligence, machine learning, deep learning, and open artificial intelligence. I will try to explain it in the simplest way to avoid confusion between concepts. Artificial intelligence make it possible for machines to learn from experience, adjust to new input, and performance tasks like human beings. They are rely mostly on deep learning and natural language processing. Using these technologies, computer can be trained to perform a specific task by processing large amount of data and recognized patterns in the data. In this case, we use the Markov chains that we'll explain later. In this case, the most visible example is the choice between a dog or a cat from an image, because this type of decision does not require us to give the order, but rather the artificial intelligence that can carry out this type of selection. Alternatively, pick the best approach to get an approximated output instinct to be a dog, 18.5%. The ability of machine to learn is present in many aspects of everyday life. For this reason, machine learning is behind the recommendation of movie on digital platform, the voice recognition of virtual assistant, or the ability of autonomous cars to see the road. It is a branch of artificial intelligence that allows machine to learn without being expressly programmed to do so, an indispensable skill for making systems capable of identifying patterns between data to make predictions. This technology is present in a myriad of applications, such as recommendation from Netflix or Spotify, intelligent response from Gmail, or speech from Siri and Alexa. In short, machine learning is a master of pattern recognition and is capable of converting a data sample into a computer program capable of drawing inference from new dataset for which it has not been previously trained. Deep learning. Deep learning is an area within machine learning that mimics the connectivity of the human brain, classifying data sets and finding correlation between them. Based on neural networks, it has the ability to prioritize learning, processing information by level. The learning happens in stages, just like a human. First, the more concrete data is learned, and then in the high levels, the information previously obtained is used to continue learning. This system has great utility potential for different types of applications in the real world. For example, deep learning network will learn to recognize image where a dog appears without having the label dog. However, currently it's used to explore the possibility of reusing drugs already known and prevent for use against new diseases, analyze medical images such as X-rays and MRI, increasing diagnostic precision in less time and at lower cost than traditional methods. Detect fraud, make recommendations to users, manage relationship with them, among other uses. Introduction of OpenIL is a research laboratory located in San Francisco, California, whose mission is the development of artificial intelligence for the benefit of the entire community. It is a non-profit organization founded by Elon Musk, co-founder of PayPal or Tesla Motors, Sam Altman, Peter Thiel, co-founder of PayPal, and Reid Hoffman, LinkedIn. The objective of OpenIL is to work together with other institutions. Our witnessed progress in the area, so much so that Microsoft this year signed an agreement with this company and contributed a large sum of money to promote and develop emotional intelligence. This program differs from companies such as Microsoft, Google, or Apple in that it is open and free, being available to anyone who wants it and with easy access. It is intended that the machine can think and behave as human beings. We can see this is game of change. Natural language processing, voice recognition, vision system, smart robots, smartphones, among others. Experiment and research on artificial intelligence, authors of GPT-2, a powerful old project capable of writing news, articulate story, poem, and even code. They refused to publish a full version fearing a rise in spam and fake news. This caused great curiosity to us, and we decided to try to build our own generator. Almost a year later, they finally released the full version.
Not faking it. Previously on the fake news scene. As my partner Santiago mentioned it just on the last slide, GPT-2 was a high-quality fake news generator. It was about to be released in February on the 19th last year, but OpenAI, its manufacturer, withheld the full version of the program out of fear that it will be used to spread fake news, spam, or disinformation in general. So, in other words, the manufacturer was afraid that GPT-2 was to be weaponized. And after receiving a lot of criticism from the community, it was finally released on November on the same year. You can try an implementation, it's not GPT-2 per se. You can try this implementation for free online without downloading anything on talktotransformer.com. Obviously, it will be rate limited because it's free for everybody to use, but you can get a taste of how it works in general. So, now you might ask, this fear behind GPT-2 being weaponized, is it legit? Is there a valid reason for thinking that weaponizing fake news may lead to dangerous results? Yes, actually yes. Weaponizing fake news can prove to be useful for certain actors. For example, in politics, you can generate false forecasts or ignite a dirty campaign, misinform about a party or a candidate in favor or against, and influence an election. In economics, you can cause currency fluctuations, particularly in closed economies like Argentina. Let me explain it here. In Argentina, for example, we are not allowed to buy foreign currencies. So obviously, as with any prohibition, you raise a black market. The dollars at official rate are around 72 Argentine pesos, our currency. But on the black market, it's obviously double the value, ranging from 130 to 140, depending where you buy it. Now, if you weaponize a fake news, like, for example, you launch a headline saying, harder restrictions to come regarding the monetary freedom, you will obviously skyrocket the price of foreign currencies on the black market. You can also do this for stock fluctuations, which is known as pump and dump schemes, but you can also find a newer variant of this scam called crypto fluctuation. It's a crypto pump and dump scam. Or you can also use this to undermine the reputation of a company. If you want to know more about pump and dump scams, they are basically when you have an organized ring claiming to have investings in a certain stock, or in this case on a cryptocurrency. They buy and buy and buy, inflating and raising artificially the price. Then this tricks other potential buyers into buying that stock or that crypto. And basically, once they buy it to a high price, all the original ringleaders or the original criminals sell their stock, causing it to go down again, to be on the lowest price possible. So basically, you can weaponize these headlines to cause economic chaos. Also, on social and daily life, you can generate this content about a party, politician, or a government measure. And even in an organized way, those so-called propaganda and disinformation devices. We'll dig into real cases now. These are emblematic cases involving fake news. For example, we have some here from the USA and Brazil. One of them says, Trump's grandfather was a pimp and tax evader. His father, a member of the Ku Klux Klan. This headline has a particular story behind. This was one of the most shared contents, fake contents, on Facebook. This was on number 1 of the most shared content and was fake. The second one says, Ocasio-Cortez proposed a motorcycle ban, which is obviously fake, but it was also the third or fourth content, most shared content, on Facebook. Then we have a Brazilian news. Man who stabbed Bolsonaro is a member of the left-wing party PT. Also, this one, once you click it on the article, it featured a picture of a PT meeting, a meeting of this left-wing party, and the man who stabbed Bolsonaro was featured in that picture. But it was later found that it was photoshopped. Now some economicals in Argentina. This is what I was talking about, a closed economy, which is pretty vulnerable to this kind of attacks. Central Bank of Argentina ran out of dollars. Withdraw your funds as soon as possible. I know that I said before that we have a restriction. You are not totally forbidden on buying. You can buy a small quota of dollars, $200 per month. And most of the people withdraw them from the banks, but some others keep them inside their own accounts. As you might know, Argentina faced a lot of situations, economical situations, where the funds saved by people were not available. Let's say the government declares that you cannot withdraw your funds. This happened just 20 years ago. So this kind of headline weaponizes a situation that a lot of people who have experienced it, who have lived through it, are in total fear of living again, of repeating again. So this might lead to a massive amount of people gathering in the banks. Another one, these were real cases. The second one was from some years ago and said, a popular biscuit factory closes due to the crisis. The actual headline named the factory. We won't for obvious circumstances. This caused a lot of people to share, to retweet, to copy and paste on WhatsApp groups or on its family groups, on every possible social network, causing a lot of people to really believe that this very, very popular in Argentina biscuit factory was about to close its doors, or that it has closed them. Then we have a third headline that says the best stocks to buy to avoid the crisis. Fun fact, most of the Argentine stocks since the last 5 years are facing a high depreciation. So even if one of them rises, it's almost certainly not advisable to buy at all. But again, having a closed economy, in this case, causes people to look for alternative ways of saving its money or investing its money. So somebody who on other circumstances will never try to buy stock or to compete in the stock market will try to take a look and say, okay, if this headline says it may be true, I might give it a try, right? And even social headlines. For example, despite the pandemic, a fourth welfare will not be paid to the unemployed population. This information, aside from at this current time not being true, it's also not official. Now, official sources have said, okay, we won't pay a fourth welfare check to the unemployed. Also, an official source haven't said, okay, we will pay. So, if you are in silence, if you remain silent, somebody else will speak for you. This might cause, in the current context of lockdown and economic recession in my country, this could lead to a violent uprising, to riots, to protests, and whatever you can imagine and name. And then another headline that says, the quarantine might not end until 2021. This is the lockdown. And you know that we have one of the longest lockdowns in the world. We are We have already passed the 200 days. So giving this kind of notice for people will obviously cause a negative impact. Now note that you have seen how simple headlines can be weaponized. We'll try doing it ourselves with our tools. This leads us to the next chapter, lie machines, building a homemade fake news generator. The first step is collection of information. Normally, who can comment about a news story? Anyone who has read it. But we are in 2020, and who can comment about a news story in 2020? Basically, anyone who hasn't read past the headline. This is the best vulnerability to exploit. People who doesn't read. Big Brother, and I'm pretty sure to say that almost any other fake news generator, will always succeed against people without reading habits because it reads way more than them. So, how does Big Brother collect news? Is it subscribed to any major network of news or to any major newspaper? No. We'll resort to something pretty classic from the old days of internet, RSS. These are news feeds. A user defines the URL for these news feeds and determines its political affiliation, call it left, right, or garbage news, and puts it into a CSV file, which is the input file. Big Brother then uses a library called feed parser to fetch the content from that feed, parse it into an output file, and then try to generate a fake news from there. Let's see the collect process. We simply issue the collect command, and Big Brother will start querying every single RSS feed we have in our input files. Then, near the end, Big Brother will display a final summary of its findings, like here. As you might see, a lot of news headlines were classified on the right wing, left wing, and garbage. Some of them were even detected as clickbaits. Okay, let's continue. So, how does Big Brother stores this news? As I said before, everything is done on CSV files. So you'll have input files for left, right, and garbage, and also output files for left, right, and garbage news. So here we got to the interesting part. How does Big Brother generate fake news from them? We have two approaches. I'll explain the hard way first, the long and hard and painful way first, and then the simple way. The full approach is the neural networks way. And you may say, okay, what are neural networks? They are computing systems inspired by the biological neural networks, where each node signals other nodes and receives feedback from them in order to learn and improve over time. Improve what? Improve the process and resolution of a certain task. How do you implement them? Using Keras, a high-level API working on top of TensorFlow, which is an open-source machine learning platform. Training a model to generate fake news from it, it's rather simple. Generating the model is simple. Now, generating a good model is one of the hardest tasks I found in my entire career. If you want to generate a model, it's pretty easy. In Big Brother, you just have to specify its orientation, left, right, or garbage, the number of iterations which will be used to train this model, the number of times the training will happen. Obviously, this number has to be really high in order to make a difference. And 3 important words to work with. The more iterations and the more specific those words are, the better the final result will be. So in the following example, because it's only an example and we don't have a lot of time, we'll use 10 iterations, which will lead to a obviously poor model. As you might see, we issue the command train, left orientation, 10 iterations using the following words: bidden, Megan, and propaganda. Let's see. This will start the generation of a model and will iterate over it 10 times. As you may see, all the words here are totally unrelated. They won't make any sense. And it says, if your results are not satisfactory, you can keep training your model further. Obviously, you have to further train this. This is a dumpster fire which makes absolutely no sense. But this is the expected, since we used only 10 iterations. So, the results were obviously disastrous. If you want to train a competent model, you require a lot of input and several iterations. This may not be the best alternative for someone who is in a hurry or that only wants to test this application. So you might say, okay, this is pretty good, I understand, but I don't have a couple of hours or 1,000 of hours to test this. Don't worry, we got you covered. And this is the fast lane, the easy way I told you before. Let's jump into it. Okay, the fast lane is using markup chains. What is markup chains? It's an stochastic method describing a sequence of possible events in which the probability of each event depends only on the state from the previous one. So, I will be giving simpler examples on the following slide, so don't worry about this definition at all. We work with sequences that contains events or objects, in this case ABC. The value of B will depend on value of A. The value of C will depend naturally on the value of B. Indirectly, the value of C depends too on the value of A, but is not aware of it. Markup chains is a memoryless process. I'm giving you this example here. On the left we have a markup model with 3 possible events: eat ice cream, sleep, or run. Look at the arrows. These are probabilities. The chances of someone sleeping after running are 10%. On the other hand, the other way around, the chances of someone running after sleeping are of 60%. The chances of someone eating after running are 30%. The chances of someone running after eating are 70%. This is just an example and does not depict any real case. It's only for explaining markup chains. Let's do another way simpler example. Markup chains can be implemented towards text generation. I want to generate a 6-word long sentence. This is a sequence of elements A, B, C, D, E, and F. The possible values can be taken from anywhere. Any text file will do. A book, a CSV dump, as the ones we use in Big Brother, or anything. The value for A, the starting value, will be hello. We have 3 possible values that could follow the word hello: everyone, mother, and world. We'll go with everyone. Then we have three possible values for C, which are nice, my, and how. If I choose how, a possible outcome for this sequence will be how are you doing? If I choose nice, a possible outcome will be nice to meet you. I'll choose mine. Now the following value is name naturally, but it could also be dog or head. So the final outcome could be hello everyone, my dog barks again. Hello everyone, my head hurts bad. But we keep going with name. Now we have three possibilities: is, was, or isn't. We'll go with is. Now the final value can be Mauro, Santiago, or not. These are the most probable words to be used with this value. And I bet you use something similar to this every day, and some of you won't even notice about it. Look at the bottom part of this. Hello friends, my name is Santiago, and we have three possible outcomes: is, and Perez. Santiago Perez is my co-speaker here. So to make things clear, I'm not saying that the Google keyboard or Telegram or any other application is actively implementing markup chains for this, but it works in a similar fashion. This is what I'm trying to say. Now, there's a great advantage on using this approach. You can generate fake news instantly. No models to train, no time to wait, no long hours, days, or months of extensively training a model just to see that it doesn't fit what you want or doesn't do what you need to do. So you can use these markup chains in Python. How? Using the Markovify library, which you can install using pip. And you might ask us, is it reliable? Well, to be honest here, the outputs will be clunky and clumsy at times, but the cost of generating this output is ridiculously low. You can generate a couple of headlines in a few seconds. It's obviously quantity over quality, because you will get faster speeds, lower cost, and cheaper results. Let's run some examples, and they will be run with the time command to measure their duration. First, before the video, I want you to see how it works. There are 10 headlines here that were built using markup chains. But out of 10, I only see that 4 of them might be somehow possible to use or to exploit. Again, more than half of the results are disposable. So let's check some of them. Facebook plans political censorship in anticipation of chaos, including Darrell ISIS. Intel expert fears Trump will hold another super spreader event. There's nothing but bad news for a goofy new pro-Trump ad campaign. COVID survivors furious after Trump refused to tell their roommates about possible life on B News. How dare you? How can you hide the life on B News? Let's check another one. This one gets darker. Kamala Harris helped alleged child sex abuse. Again, 1 out of 10 seems to be exploitable or a candidate to be weaponized. Check in this screenshot on the bottom part. You might see the time spent running this command, the generation, half a second. You don't believe me? Half a second again, but check this one. Iowa is a lie. So to everybody out there telling me, hey, I'm watching you from Iowa, I know that you're lying. Let's check this video. As you see, we can run this generation, and we can get 10 headlines in half a second every time. Sometimes it will take a little more, a little less, and obviously sometimes you will get all 10 headlines to be clumsy, and sometimes you can get a vast majority of them to be suitable for weaponizing. C-word of political malpractice. I like it, that one. So, okay. Again, to repeat something that's pretty important for markup. Quantity over quality. Remember this. So, I want to explain in an informal way for everybody at home how both approaches works. A trained model approach. Let's say that for both cases you are not a native English speaker, just like me, and you say, my name Mauro, literally, my name Mauro. In a trained model approach, your teacher, your English teacher, educates you and explains in full linguistic detail why you are wrong, citing the corresponding grammatical and syntactical rules, and corrects your phrase by citing an example he or she knows for sure is correct based on his previous knowledge. So your final output after all that English lesson will be, my name is Mauro. Now, the markup chains approach is a little bit different. Let's say, again, you're not a native English speaker and you say, my name's Santiago. Same error, but different handling. I am not a teacher, but that phrase indeed sounds odd to me. I'm used to seeing the word is normally placed between name and a name. So I can't cite English grammatical or syntactical rules, but I'm sure that is should be placed there, based on previous time I saw it done that way. Now, the advantages and disadvantages of each method. Training a model. It takes more time to complete, but improves over time. Can be retrained as much as you need, increasing its accuracy. It's bound to a specific language, the one in which you have trained it. And it has a heavy use of dependencies and resource consuming. On the other hand, the markup chains has almost instant results, but a couple of them will be still clunky. Faster results, but lower accuracy. Sometimes you will see headlines that make no sense at all, like the one of Trump hiding, the life on Venus. Ah, how dare. I still can't believe he hit that. It remembers me of the Windows XP bug. Bosch hid the facts, that you can write it down on a notepad and it will go like with corrupted characters. And continuing, it's a probabilistic approach, so it measures the probabilities of a word appearing right after another word. It doesn't understand what the word says. That's why sometimes it creates totally unbelievable headlines. So, since this is a probabilistic approach, you can make it work instantly with any language. Actually, Big Brother was a project that was focused on Spanish misinformation for my country. And once we noted that we could use this in English, in Russian, in French, in any language, we were absolutely stoned about it. So markup is also lighter and has almost no dependencies. You only need Markupify. You even can run this exercise without installing TensorFlow or Keras or anything that's heavy for you. Now we have tested a little bit, we have played around with a hybrid model. You can generate outputs with markup based on those from a trained model. you can also generate outputs with a model trained from the headlines generated via markup chains. This may help you on a specific case where you need fine-tuning on the way you want to lie. So you really have to know what you're doing here because it's highly experimental. Every time we try it, we got a lot of problems, but you can really fine-tune your lying methods. Now it's time for even a funnier part, and we can let aside the probabilistics and the model training and the voting part, and let's jump into a demo, spotting fake news in the wild. So there's a special option inside Big Brother that is called the replicant test. Once you have collected enough information, enough headlines, say 100, you should try the test switch. This test will launch an interactive testing menu, the replicant test. This test will try to generate fake headlines using markup chains, the method we saw just before, and you will be prompted to choose one of them to be hidden among real headlines. Then you can ask a friend to try and guess the fake headline interactively, helping you to see if your sources are useful and reliable, and if you're on the right track with your fake news generator. Now, I have recorded 2 sessions that I want to share with you, and I'll give you some time to try and guess the fake headline. Let's go. I will click pause on this video. So, here's the replicant test. You have 10 headlines, numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Please take a moment to read them. Try to figure out which one of this is fake. I'll play the video in a second and you'll have around 40 seconds to guess. Good luck. Remember, you can try to guess them but it's pretty easy to lose. Okay, we'll go. Time's up. Okay, let's go to the second one. And you may say, I know, you may say, wait, how do I know you're not cheating on me? We'll see in a while. Again, same situation, you have 10 headlines. Try to guess which one is fake. Good luck, you have around 40 seconds. Look carefully. Sometimes you might choose the most funny, the funnier headline. And sometimes that's true too, so it's pretty easy to fall for this. You say it's number 5? Sorry, wrong answer. The faint headline was, having socially selected officials makes a clean environment a right. Other states should follow. So now, as I said before, you may say, hey, I think you're cheating on me. That one looks pretty right, or that one doesn't look fake at all. So I urge you to don't believe in me, don't believe us. If you do, this talk was in vain. Google every headline and see by yourself that they are actual news stories from well-known sites. These slides will be published so you can go back to the video anytime you want. Of course, you won't be able to find 10 headlines because there's one that doesn't exist. It's fake. Try Google Try to Google it and you'll see. And I know you may say, wait, I'm too lazy for Googling 20 headlines. Also, I'm busy scrolling my Facebook feed where I can get better news. Okay, that's why we started this talk in the first place. So, time to say goodbye. Conclusions. It doesn't take a dedicated artificial intelligence research lab to produce fake news quickly and massively. Anyone can recreate this experiment on a very low budget setup and use it to their own advantage. Say, and I'm giving a crazy idea that I haven't tested, but I'm sure some of you will like to do. Raspberry Pi, Big Brother, and you have your own portable fake news generator for the world. And machine learning is unstoppable. Absolutely all available information can be classified somehow into patterns and exploited for the particular benefit of a system, even for biased ones. I want to give a special shout for Omar Santos and all the GrayHat staff for this opportunity, and a special thanks to my friend Florencia Diaz for helping us developing Big Brother in the first place. Please feel free to follow us on Twitter or on GitHub. You can find me on every social network as Mauro Eldridge. I'm happy to engage and to exchange information or exchange projects or to discuss different things. You can also find Santiago on Twitter and GitHub and our DC. Our DC loves talking about hardware hacking, open source intelligence, and social engineering. So feel free to drop by and we can make a pretty interesting exchange. Also, don't forget to grab a copy of our Big Brother tool here on Mauro Eldridge-Big Brother. It was a pleasure to be here, and if you have any questions, please feel free to leave them in the chat and we'll be more than happy to answer them. Also, feel free to drop any question you want to do privately on Twitter. So thank you.
Welcome back. The next presenter is Felipe Pires, and Felipe's presentation is titled Pivoting and Exploitation in Docker Environments. Thank you so much, Felipe, for your support, both for Red Team Village and also for the support of GrayHat. We're looking forward to your presentation. Thank you so much, and take it away.
Hi, everyone. I'm so glad to be here. And today we're going to talk about pivoting and exploitation in Docker environment, right? So, my name is Felipe Pires. I am Brazilian. I'm living from Brazil now. I'm living in Brazil now, and this is my contact in social medias. If you have any questions, any doubts, or maybe you can share with me your knowledge. It's very important to us to exchange all those informations, right? So I have been working in a hacker security company as a global research manager. HackerSec is an international company responsible to provide many trainings with a cybersecurity and a blue team and a red team and a threat hunters and awareness with the companies, right? So the very awareness program and as well, it provides some services about the pentest as well. And I am a founder of the malware analysis course that I created. And during this course, I'm talking about the basis of this topic, right? And I work in Zup Innovation. This is a Brazilian company, like a software house, but the focus here is to build many different products, right? So we have four products. By the way, it's open source code, so you can try all those products, and you can try, improve, and suggest many things. So it's very interesting. So our idea in Zup Innovation is to create a big community, right? And my role here is I'm a research manager, and I'm responsible to Zup Security Labs. So this team is responsible to try gain many vulnerabilities and find 0 days. So our idea is to working with the focus in the similar hunting, because in the market when you talk about the threat hunter, usually this kind of professional works below the SAMSOC or maybe CSERT. But my idea when I received this challenge is to put all those guys, all those skills or those people inside this team with the focus in research, right? So I'm not a writer, but I have a privilege to write some articles in Pentest magazine and Forensic magazine in a Hackinani, and I published one article in the Cybersecurity Hub. So the idea here is not to publish 0 day or try to hack in an essay or something like that, but the idea is just to provide some knowledge of base, right? Because this is my main point here. It's talk about the base. For example, today we're going to talk about the pivoting, but you need to understand all those steps until you arrive on the pivoting technique, or maybe where I can put these techniques, to try. So that's my idea when I publish some articles, and I continue to publish in another magazines, in the Pentest again, and this is iExpert magazine. I think it's from Europe, but more known in India. And if you would like to read, you can on these magazines or maybe this website, right? So this is our agenda today. So we're going to talk about the pen testing, as I mentioned, because I need to put all those people in the same base. Probably you know about this, but I will talk more fast because, just to put all those people in the same base. Executing a pen testing, you explain some methodologies, but it's very fast. And after that, we'll talk about the techniques, right? In the end, we're going to talk about the question I can answer to you, right? So, first of all, what is pen testing? It's very simple. In simple words, basically, is a security testing, right? It's the simulate of the real attack in your own environment, right? So the idea here is to provide, or is to not provide, but to try your security products in your company. So the idea is to simulate a real attack in any features of the softwares, in any applications, or in the systems on the network, or all the infrastructure, right? So this is the simple idea of the pen testing, right? So, and what the kind of tests or types we have when we need to execute. The first of all, it's black box. Of course, you can imagine it's similar to hacking or executing by attacker, right? So when you don't know any information about the company, just to know the name, or just to know about the I don't know, the name of the president, or another information, and you need to make a research, right? You need to make a research in a Google, maybe in a GitHub, to try to find any keys or any passwords in a GitHub, for example, or any codes. You need to make this reconnaissance steps, right? Because you just have the name of the company. For example, the Philip company, you just have this name, and you need to hack this company. You need to gain many access. You need to, but you don't know if this company has a for example, some databases, what the database are, for example, or if you have any mobile applications. So that's the black box. You are in the like a darkness. You like the black, right? So in the white box is different when you have, for example, the scope, defined in the company, gives you the defined scope, like you need to try, for example, you need to hack the API, you need to hack the web application, we need to hack, for example, specifically API gateway, for example. So you have this mailing scope. Usually you know about the all infrastructure or all the code. You need to provide some a code review in this apps, for example. So this is when you're gonna talk about when you talk about the white box, right? In the gray box, I think it's but it's basically it's the mix of all those types, right? So you have some informations of the company, you have the name, maybe you have some applications, but you don't have any, or you don't have another's information of the company. And you have, for example, the one goal, for example, to try hacking the Active Directory of this company. So, but this company has Active Directory, right? So, but when you talk about the black box, you don't know if this company has for example, Active Directory, or maybe using Samba, or maybe using another open source code to for example, to organize of the users, for example. So in the gray box, you have this mixes of this information, right? So when you talk about the execution or the execution, not the execution pen testing, the practical, right? You need to search some like a methodology, right? So I was just talking about not exactly methodology, but you can put all those ideas when you execute in the backup process, right? So we can choose, for example, the PTest, this penetration test executed standard. It's usually 7 steps. Like the first 6 are reconnaissance. You need to understand all those information, the company. You need to enumerate many information. You need to exploit, post-exploitation, and something like that, right? So this is this is one process that you can use like a methodology, right? So you have the WASP. I think many people that are hearing me now know of this community, like not community, but organization, right? It's very interesting you can, for example, invite you to stay together with us to improve more information of this organization. It's very important. It's the focus, of course, in web application. And many times when you talk about the web penetration testing, the people using this kind of methodology, WASP top 10 with the top 10 vulnerabilities or kind of exploitation that we can use in different strategy in the penetration testing, right? So, first of all, when I try to create this presentation, I worked in Poland, actually. One of my tasks is to improve my skills. So I used in that time the Hack the Box platform. I think many people know this platform, and this is one of these machines that I was hacked in that time, right? So of course this machine it's not available now, so it's okay. So it's not I won't show you any information for you now because of course the machine is not available more, right? So the first step to be a reconnaissance steps, right? So I think this is a demo that I would like to do now during this penetration testing that I did in the past. So first of all, we need to make the reconnaissance step, right? I need to understand what the vulnerabilities maybe, or the ports are open and something like that. So the first of all, when I make any pen testing, maybe I like, I think it's not automatic. It's not, maybe it's not a very interesting process, but this is it's my opinion. I think I like to understand how this application works, right? So if you see here during this presentation, you can see I putting the mouse below the pages to try and understand what is the redirectory website or link this page follow, right? So here we can see the blog. Maybe I could try here, because the blog usually using articles and many articles in the page. Maybe sometimes you can use the SQL injection technique. I saw the blog when not blog, but we see another contact form as I am opening now. Contact form, for example, you can use different cross-site scripting techniques, right? Or maybe cross-site script stored, or another different technique, right? So this is my investigation, the first beginning step in the investigation in the stepping of the penetration test, right? So this is the platform, the application, Azure, and here we found the ports open and the protocol, right? And it's very interesting because we found here the version of the open SSH. We found here the Apache, and by the way, the version of the Apache. And another interesting information here, and here the first step that I was starting to think it's possible I was staying inside of the container environment, because here we have another port using this, using the same protocol, right? And here we have another, if you can compare, you have two different web services, right? You have here the Apache Tomcat, and here you have the Apache in another port, of course. So here we have another web page that we can open, right? So the first step is to try open this web page, right? So when you put here, take a look, I received the authentication page, the authentication information, right? So it's very common in many companies, as you know, probably, right? So I talked this topic in Poland in the Confidence Conference, and when you talk about the old guys, and one of these guys talked to me with the many times that he actually visited many companies, and many times that this company has the same problem that I will show you now here. Take a look what I put here in the box, right? So I'm using the default password admin. And as you can see here, it's the full password, right? And this is the one when we are executing any or some pen testing, it's very interesting when you have some upload possibility, right? Because this is, I think it's usually the penetration guy, when you look at this kind of opportunity, I think the guy stay very excited, because if it's possible to upload something inside this environment, maybe I can receive a reverse information, right? So if you see here, maybe this we can suppose that this application, it's I don't know, the publicity company or advertisement company, because we have like here, it's like a Mac OS platform, right? The computer, we have here upload of images, so maybe it's a advertisement company, or make a treatment of the image, and we continue to explore this information. Here we found the zip upload, so we can upload the image and zip, right? 2 options, and I will try continue to explore this page. We have maybe here we have the all articles, maybe using the SQL injection in another contact form, and I could using the SQL injection. Okay, and I return again to the first page, because the next step is to try to continue to enumerate many informations. Maybe I could try and enumerate the subdomains, or maybe explore the directory. So this is the idea when you try to exploit. I will pass move one to see all those information. So here I'm looking here. I put the command wrong. It's interesting, because usually in the real life, many times we put in the command wrong, right? So we need to define all those command here's, and I forgot, and then the slash and fuzz. I using the wfuzz. It's a very interesting fuzzer to try looking all those directories it's available, right? To try access. And here we can see found some archives, upload, and users, right? So do you remember that we are looking at the first application, right? The AT port, right? This is the first. So we have here the response of the website, the web server, and I will try to access this directory, right? So when I put here and I try access, I receiving the negative, right? The access. And if you see here, when you put all those information in your web, I receive the error. If here you can look a simple another kind of error, I think, because if you the attacker, for example, suppose didn't use the Nmap platform to try looking the apps or the ports open or the servers open, but when they use this attacker could be try, for example, looking this directory image. Of course, the servers don't give the access, but here you can see the answer, right? So you can see basically the application Apache, and you can see here the version, and you could, for example, to try and find any exploit is available. You can see here the Ubuntu version, not version, but Ubuntu server. That is now of this server has a Ubuntu server, right? Because it's a very important information that usually the development team guys didn't get to put this information easily for any people, right? It's not a good, like a misconfiguration error, right? So after that, I tried to access the users pages, and here we found maybe a support page, right? Because we have here AGR 3 members login, just 3 members, right? So maybe this is the mainly guys responsible to access. I tried to put in the default password, but invalid logins detail, I received the answer, and I put root. It's the same case, I received the same error, right? So we need to try explore more information of those applications, right? So another kind of tools that I would like to use, if it's my characteristic that when I executing some pentesting, or maybe a research, or maybe like a threat hunting service, I like to use more than one tool to execute my services, right? So here, for example, I used the OWASP Debuster. I think it's very known. It's provided by OWASP organization, right? And here you can see the report that the result of my action, right? I like to use more than one tools, because we can see different results sometimes. So I think it's very interesting, So here, if you see here, I found another page, the secret doc PHP. So when I try to access this page, take a look what I found here. I think it's any conversation in this page, maybe the support guys, right? So here we have 4 users. You have a Tatara, you have a Noro, you have a Kanek, and here you have a Eto. So maybe you can see here this conversation. Maybe when this guy, for example, Kanek explain or talk here, these guys are talking a supposed RCA, right? So remote command execution inside their environment, right? So take a look what these guys talk here. Also, please replace the file servers with the ASAP. It's not good to use it, right? So you can suppose maybe this is a share screen of this conversation. Maybe they're using to maybe auditory, or maybe another different services, right? So let's continue to look in this conversation here. And here, maybe you can see all those information when the Eto talk about maybe the content, right? So also, guys, I found this file users on desktop with contents, and he says about the user doc text like Raptor Huli here, but this information or in this file are content, right? So here we have interesting information. So the idea here, take a look. Noro says, blah, it's impossible to get into our servers, right? And before I will check the IP logs and eat them. It's a joke here, of course. So he will investigate more deeply all those logs, IPs, right? So because probably, we can suppose that Noro is responsible to the IPs or network. Probably he is a network guy, right? So, and here in the end of this conversation, he says, by the way, Kanek, I needed the access for your remote servers. So, because probably Noro, even or since the network guy, he knows, of course, all those IPs in this environment, right? So, but he, of course, didn't have or don't have any passwords, of course, because it's not safe, right? So, Noro make a request here, Kanek, I needed the access for your remote servers. And here, take a look the answer. I look Toka. So maybe if you read all those information, maybe you can you didn't see nothing interesting here, but you can find very interesting information here, because I love Toka is the password of this machine of the Kanek, right? And here he's talk about another things, but just not interesting information. But if you see here below, you can find this information of the chat. Of course, chat is unavailable at the moment because probably it's a screen of this conversation just to this company using to auditory or another different compliance, right? So we have some informations here, and we continue to try to improve, because if I will put in pause here, because we have the one web application that I could upload not any, but 2 different files inside the application, right? So I try to upload the image or maybe the zip information. So this application works in PHP, so I know of this language. So I create a simple shell so I can upload all those information inside this web, right? So, but how could upload this information inside this app? It's very, very simple. Why it's simple? Because I know, right? We have the vulnerability in sometimes. I think you already heard about this vulnerability. Zip Sleepy. It's a vulnerability inside of this zip, right? The zip file. So here you take a look of this vulnerability. So Zip Sleepy is spread critical archive extraction vulnerabilities, right? So allowing attackers to write interference on the system, typically resulting in a remote coding execution. That's our focus now, right? So the vulnerability is exploited using a special craft archive that holds directed traversed file. So this is a technique that I could be using or used here, right? So we have the zip vulnerability in this environment, right? So basically here, this explanation of this vulnerability. So we can try using. So I remembered during that exploitation that I can try to find any tools that I could be using in this vulnerability. So we found a Everlack, right? GitHub, we have this code, and I could create this package, right, of this zip to upload all this information. So here, I download these tools inside my machine, and I use here, as you can see, right, I download the Everlack. It's in Python. It's wrote in Python, right? Basically, I using the Python 2.7, and I call the Everlack Python. I put this shell inside of the zip. I set here the Unix platform because it's Ubuntu. I think you remember. And I set here the path, right? So var www.html, because usually this is the path of the web application, right? So after that, I created the evil.zip contain, right? So here I have the evil zip. I could upload all this information inside my victim machine, right? So after that, I have my shell command, right? I have here the command execution. So I can set, for example, the if config to try looking the IP. If you look, I think it's it's not bigger. It's small here, but the IP here it's 172.20, right? So here we have the class B in the network. So it's take a look of this important information. And here you can look in the version of the server, of course, and you have here all those pages inside the web, right? The web application. So you have the archives that I tried to access before, and I can access. You remember the blog, contact HTML, the image, and here you can find the secret doc.php that I found. Do you remember? And this is in here my shell. So if I have common execution inside the network, of course I can try to set some reverse shell execution, right? So this is the next step. So I open this port in my machine, and now I have a shell. If you see here, take a look here, we have a Docker env. So because if you remember the first IP that I put in when I executing the Nmap tools, I have the class A, right, to try exploit. But when I get the access, I am in the class B, right, 172. That is, we have a different networks, and you have a Docker env here, as you can see in this image. So we are in the Docker environment. Of course, we have a user data access, but we need to escalate a privilege. But that's a point that I would like to talk to. All those steps is to put everything in the same page, right? So when I can put this pivoting techniques in practice, right? It's in this moment, right? So because I already have the first victim, I am inside of the network. So this is the next step, using a pivoting techniques, right? So here I just show some information, the same information that I saw in the command execution, because now I am inside. That is, I can see here the same information, archives, blog, and images, and secrets.php, and users, and another shell.php, right? So if I thought in my pen testing in that case, I thought, for example, if I can upload some file inside of this environment, and I have some privilege, I can try to put my key inside of the root machine, and maybe I can have the root access, right? So I created here my private key, right? And I generate it. The name is hacker.pub. And after that, I using the same technique, right? So I set here the Python 2.7, every like the .p that I call it. I set the same system of operation, right? And here I set, for example, the root .ssh, and I set my private key. Why I do this? It's very simple, as you can see here. I access all this environment here like a root. So the first attack I had the wdata access, the user, the web users, but now I have the root Azure in this environment, so I can read all those informations in like a root, right? So as you can see here, it's a very interesting, because the first when I get the access, again, this is the class A, right? But when we are inside of the victim machine, we are in our class B172. Let's take a look. It's very important information, right? So here we're gonna talk about the pivoting techniques, because that's a mainly point that we're gonna talk today. So I wrote in a pentesting magazine, this magazine, about this kind of, it's similar topic, using pivoting as a attack will happen. So here I using my not the same machine, but I create my own environment, and if you want, you can look in this article. You can prepare the same machine, you can configure the same machine, and you can training your skills in this environment, because we have the application vulnerability. I explain all those things in this article, right? You can create your own environment, right? So the pivoting technique, it's usually in the first, when you get the access in the first compromised system, and you can, using this kind of technique to gain access in all machines, but not in the same network, in different network. You can gain access all those networks, right? In the other hand, you can see, as I can see, it's a technique that attacker, maybe a penetration tester, or maybe whatever, are trying this testing to move laterally inside a corporation, right? It's like a jumping, right? So, for example, I am an attacker, for example. I am in the class C192, right? IPs, and I gain the access in network 172. I'm in the class B, but inside the network we have a different connections. We have different routes inside this network that I am gain the access, right? So how it's possible to gain the access in another, it's another range of the IPs if I don't have access of this range. It's possible if I using a pivoting technique. I can jumping using, of course, the victim machine to gain assault, like a jump to another machine, right? So here I will show you part of this attack, or part of this information, right? So here I will using the connect access, because the connect it's the main guy in this access that I am executing this pen testing here, right? So I get the access because if you remember, I had the root access, so I got all those passwords, right? So here you can see it's a class B, right? 172.20, right? So I am inside the Connect Azure, right? This is the machine of these users, right? So here we have any informations. First of all, we have the note.txt, right? So if you see here, we have the interesting information. Vulnerability logs has detected, right? So I shut down the resistance function on our server. Please ensure that no one gets access to the test account. So here we have interesting information, right? Because we have an application here. In this application, GOGS is vulnerable, right? So not some, but many times, if you, I know many people, many times working in their company, and sometimes need to write something in a notes page or another different different editor text, and sometimes they have been written some important notes inside this document. So as you can see here, right? So vulnerabilities in GOGS. That is, we have the vulnerability in this application. And another very important information, take a look. This is about test account, right? Because here it's a danger, it's a it's an alert or whatever information that you can imagine. Please ensure that no one gets access to this test account, right? So it's very important, because we in this account, as you can see after, it's important information, right? So here we continue to read all those information, because we have here the note doc text, but here we have another notes. It maybe, if you see the green color here, maybe it's a application, but it's not in that case, or in this case, right? So here, let me check here. I will read. Yes, I read here. So take a look. I've set up file servers into the server network, and Eto, again, Connect are talking with Eto, right? Eto, if you need to transfer files to the server, can user use my PC, right? DM me for the access. It's very interesting if you see here, because Connect, it's a support guy, right? And the other, if you remember the conversation guys in the support, the Noro requests the password to access the remote server of the Connect. So maybe Connect, it's an important guy here, right? Because Noro spent some time to talk to him in the past and request, by the way, the password. And here, Connect talked to Eto. If you need to transfer some some files to the server, can use my PC. So maybe, here I am supposing, right? So maybe Connect has another PC, my PC, and maybe this PC has a test account, right? So I am supposing here, right? So if you continue to read here or to looking, so we have some tips in this exploitation. We have some tips in this testing, right? So here we found another keys, and here take a look what these keys we found. We found the Connect at Azure. This is our access, right? Perfect. But here, take a look what we found. Connect _ pub at Connect / I forgot of the correct sign on here now, PC. So here, this is the test account. This is the machine responsible for probably we have here the important information. So maybe here it's another Docker, right? Because we have a Docker. We have different Dockers inside this environment, right? So let's continue to do this pen testing now here, right? So now we have some information. We have a Eto, Azure, Noro, Tatara. So of course, during this pen testing, I'm found all those keys of all those users, but the Connect is most important in that case that I did it. I did that. So because another user didn't have the important access, the important privilege, right? So let's continue to explore all this access guy, right? So here you can compare again the IPs, all those information. So this guy, it's a very important guy, but he have many problems in the configuration. Take a look here. We have all the cap keys inside the server, right? So here we have another, as you can see, he connect the cap key, right? Because this is the key the caps. right? And I set here the interaction connect doc backup, and I try. If you see here, I try to using this user. Do you remember who is this guy or who is this account? This is the test account, right? So here I am setting the IP of the container, right? One of these containers inside this environment. And here, boom, we got access. So now I am inside this another environment, right? The connect environment. If you see here, now we have another information. Take a look at this. Because first of all, we were in class B, right? But 172.20.10. And here we have in another, another, it's the same range, of course, but we have another network inside this machine. We have 172.20.150, right? But we have another, another network port here. This is 172.18.0.200, right? So here we have another network. So now I can try to using the pivoting technique because I have a different network inside this environment, right? So here we have another network to try explore. So here we gonna using the pivoting technique, right? So because if you remember, we have here the first victim machine. It's a connect environment, the connect Docker, of course. This is this machine is in the network B, right? The class B 172.20, right? But inside this Docker environment, we have another Docker, right? Another container that this machine of the connect, right? The connect pub, because this is the test account that they have. Inside this machine, we have another Docker, right? So this machine is in another class B, but 172.18, right? So I need to get access in this network, but I just can access this information if I'm using the channel, using this pivoting technique. This is a channel that I will creating now, right? So here I will show you as possible to create. This is one of these techniques because we have many different techniques. I will using the SACT protocol, but you can use another different, or maybe make the same protocol, but you can using another different tool, right? So first of all, here I will explain using this key. Do you remember? Because I created my private key here in this case, and I use, of course, the root account because I wanted to have the main access in that case, right? I using the port 22, because this is the full SSH port, but I open in my machine this port is 1717. I started to listening this port inside of my environment, right? So here we have the first machine exploited, right? 172.20.115, right? Using the 22 port, right? But I am opening this another port inside my environment, right? So here again the access, and I have wrote until this range, right? So take a look. This in very, very interesting information. Take a look what this IP I've set here. I set up the 172.21.50, right? So this is the host IP, but here I am inside the Docker environment, right? So 172.20.10. Take a look, man. It's very, very interesting here. So now I have this port, 77, right? So I need to access this environment using this port. So this is my IP, of course. I have a a villa to access this environment, of course, because in the Hack the Box. So you can see here different classes, right? So I am using now this information. I am setting here the route again. And here I will try to access this route using this channel, right? So here I will set the same SSH protocol, but here I call it the connect_pub. This is a test account, if you remember. And I set here my local host, right? But because I need to set my local host here, because I will use here this port 77, the port that I was open in my machine to listening, right? So in here I set another machine 172.18.2 in the end, because this is the gateway machine, right? So here, if you see here, when I just will explain here again using the same port to try access, but here I open another port. If you see here, the 300, right? So here is the port that I opened, right? So I put in the wrong password, and I will open again here. It's I love token, as I mentioned in the beginning, if you remember. Okay, so here I put this information in here. I got access inside it's another machine, right? So here we found again the same IP of the host, again, the host container, right? And here we have another access in this another network, right? So here we got access inside this victim machine. If I put so here, of course, I have two different routes, because I have a route to the 172.20, yes, and I have another route, it's a 172.18, two different route right here. In the end, if you see here, for example, take a look, because I opened the 300 port, right? So I set up here this information, and take a look what this interesting information here. We found here, what we found here, the GOGS application, man, this is another application that we have inside this environment, right? So here, as you can see, if you remember of the connect nodes, this application is what? Is vulnerable. So this is another part, another step, but this step, maybe it's another talk, another speech, right? So here I finish this demo in this presentation because we got access inside this environment, right? So if you have any question now, I am available to you. Sorry for talk more fast, maybe. And this is my contact again. If you have any question or another thing, I am open to talk to you now. And again, thank you the event to this invite to be part of this event. It's a pleasure to me. And if you have any question, please let me know.
Welcome back. Our next presenter is Cedric Owens. Cedric is actually a really good friend of the Red Team Village. He's currently an offensive security engineer with past experiences as a blue teamer as well. His talk today is the red techniques and blue considerations in modern tech environments. Thank you so much, Cedric, for supporting the Red Team Village and GrayHat. So please take it away.
Thank you, Red Team Village and GrayHat Virtual Conference for having me. I'm super excited to be here. My name is Cedric Owens, and I'll be talking about red techniques and blue considerations in modern tech environments. So before we get started, a little bit of background information on myself. I'm currently an offensive security engineer at a tech company in the Bay Area. I've been dedicated on the Red Team side now for about the past 4 years. And then prior to that, I was actually on the incident response, threat detection side of the house. So I really enjoy looking at security from both perspectives, and I think it really helps bring things together for me personally. I also enjoy writing posts, blog posts, and various tools that aid both red and blue team members with the end goal of pushing the security needle forward for defenders. Personally, I have an interest in Mac OS, just given that Windows has had such a large market share for so long. A lot of the techniques and focus have been and continue to be Windows, which totally makes sense. But for me, there's a lot of unturned stones on the Mac OS side, and it makes it a really interesting place to dig in, do some research, test ideas out. I'm thankful for guys like Chris Ross and Patrick Wardle, who've been doing Mac OS security research for years, like long before it was a thing. And they've laid the foundation for guys like myself to come along and build on top of. So I wanted to give them a shout out. I also enjoy 80s and 90s nostalgia. You can't see it, but I even have a Stranger Things shirt on just because it reminds me of the 80s, at least the first couple seasons for sure. And a couple of the movies I enjoy is The Last Dragon. If you haven't seen it, definitely worth a watch. If you're into like Kung Fu in the 80s, you'll love it. And Golden Child, I can keep going down the list of Mario and all sorts of other things that bring back nostalgia for me. So those are things I enjoy sharing with my kids and with my wife. And I am on Twitter. I go by the handle @CedOwens. So occasionally I will post things on Twitter that might be of interest for defenders as well as offensive engineers. So for today's talk, I plan to start off talking about modern tech stacks and deployments. And I'll pause there for a moment and kind of caveat that I'm focusing more on Bay Area tech companies when I say modern tech environments. Now, I'm not saying that companies that are Fortune 100 or Fortune 500 companies, like a lot of the household names, the companies that have been around for a long time, that their environments are not modern, because they are. I'm just saying that the tech stacks are different. And so I've kind of, since I've been on the Red Team side, I've been much more on the Bay Area tech company side of the house, and that's what I'll gear the presentation to. But there are some notable differences, and a couple of the differences might include like your Fortune 500 or 100 companies might predominantly have Windows endpoints, whereas you come to tech companies in the Bay Area and it kind of flips. So we'll talk through what those tech stacks and deployments look like in modern tech environments. Also, plan to talk about outside-in attack paths and considerations, as well as internal attack paths, and sort of where this comes into play, because you might be thinking, well, like where would this talk go if I'm gonna do the MITRE attack matrix? I've rolled that out. I've got my bases covered, and that's actually the perfect place where a talk like this will come into play, because now that you have the ability to build detections and you've got some base detections, this talk sort of comes in and takes realistic attack paths that I have used and other red teamers have used that are going to likely be targeted in your environment if you're in a tech company, and really helps blue teams to begin a posture ahead of time proactively for those types of attacks. So let's jump right in. So as I mentioned, there's definitely differences in how what the environment looks like in most modern tech organizations. Starting with endpoints, you find that it's mostly Mac OS, as I mentioned earlier. So it's not uncommon at all in a lot of Bay Area tech companies that you may find 80% or more of the users' workstations or laptops are on Mac OS, with maybe 15-20% being Windows. So kind of flip-flop of what the rest of the world is used to. And there's a concept of, well, I won't say it's started by the Bay Area tech companies, but the whole idea of AD federation and integration is used heavily in Bay Area tech companies, where you have an identity as a service solution, and you may have other portals and services, and they all use Active Directory credentials. So you'll see those types of setups in tech companies. There's also a concept of realms, where you have one realm where users and their workstations and their productivity apps live. You may have another realm where development and testing happen. Another realm where your live applications or your live code lives, maybe customer data. So there's a concept of realms, and we'll talk through that as well. The CI/CD pipeline is pretty much at every Bay Area tech company that I've encountered, and it basically creates a modern, consistent, repeatable way to move code through various environments until it goes live. And so we'll look at an example of what that looks like. You'll also see cloud services in modern tech environments, where like years ago, a lot of things were hosted on-prem, and now you're starting to see a shift where either it's hybrid or maybe most of the stuff is in the cloud now. And then modern tech companies also typically include some method of secrets management, which may be organized and secure, or it might not be so secure. So we'll talk about those as well. So from an endpoint management perspective in most tech companies, one solution I've seen that's pretty common is Jamf. And a very high-level overview of it here is that there's an admin server that, like a subset of your IT engineers would administer and control. And the Jamf admin server pushes policy, scripts, configurations, etc. over to the agents. And in this case, the agent is any MacBook in the environment that's managed by Jamf, which means it has an agent running on it. And for each managed endpoint, it has the ability to perform self-service, which is also run through Jamf. And essentially what it is a list of apps that IT has already vetted and approved, and that users can just open self-service and install it rather than having to submit a ticket, maybe wait a couple days to get the ticket resolved. It's pretty efficient, actually, pretty neat setup. So another look here, you've got your Mac fleet getting its configurations from the Jamf management server. And then on the back end from the Jamf management server, you have your Active Directory binding. And so that is what allows your users to log into their Mac with the same credentials that they use, like to log into like VPN portals or other publicly facing login portals or other services in your environment. That Active Directory Federation is used here for endpoint management as well. And one thing to be aware of is in a lot of organizations, you'll find that admins do perform some type of remote management of the Macs. And a typical way what that looks like is each Mac will have SSH enabled by default, and there might be a local account on the Mac, such as like a Jamf admin or Casper admin or whatever you want to name it, but some account that's local on the Mac that has sudo rights with the ability to SSH in, and IT might use that account if there's an issue or they want to administer something on an employee's workstation. And so, of course, that can pose attack paths, where especially if that password that's used for the remote management is a static password, meaning it's the same password on every Mac endpoint, like that opens the door for an attack path, kind of similar to the Windows side prior to LAPS being rolled out. So just something to keep in mind. From Another way of looking at the federation that's used in common tech companies is you have your publicly available login portals, or some call them identity as a service solutions. Examples like Okta and OneLogin that are publicly available, so you don't need a VPN or anything to get to them. You just browse to the site. The employee logs in with their corporate username and password, which ends up being their Active Directory username and password. And then if that authentication is correct, what next happens in most environments is they'll get a 2FA. You have to do 2FA, which in most instances will be a push. Like most companies will have employees install an app on their phone. So once you authenticate, second step, you get a push notification or pop-up on your phone asking you to accept it, deny it, report it, that this is you logging in. And once you click accept or yes or whatever that button is, it lets you in, and now you have access to corporate resources. Things such as a lot of your productivity suite items like email, messaging, internal wiki, SharePoint, Confluence, Pages, your document storage solutions, maybe Box or Google Drive, and then production apps at the bottom. And to me, that one's kind of interesting because each environment or each company may have their own homegrown production apps that they grant access to certain users to. Maybe they control that through Active Directory group or a separate LDAP group. And if you're in that group and you're authenticated inside of your identity as a service portal, you then are able to access production apps as well. And how that looks could also differ. Like some organizations just might let you click the little tile in your portal and let you right into the production app. Another one might require a different set of credentials to log into the prod app, or another 2FA push. So what that implementation looks like is different, but this is pretty common in what you see in a lot of tech environments today. So I briefly mentioned earlier about the CI/CD pipeline and how common it is, because it's a really neat way of controlling and getting code from basically across various environments over into your production environment where it's live. And again, this looks different when you talk about what's being used, but the general flow is pretty similar across most tech companies today. And a general example might be like a developer goes to internal Git, adds a repo, and then when they're done with their code in the repo, they may make a commit to trigger a Jenkins build. And then in Jenkins, you can version it, do some other things, and from Jenkins start to actually schedule things for deployment through whatever system you're using to actually start deploying your code into dev, to test, to staging, then to prod, kind of following that process. And so it looks different at every org, but one thing that's interesting about the CI/CD pipeline is even if every server in the pipeline is very well managed from access controls, it's patched, doesn't have any blatant vulnerabilities, but so that might be the case. However, there's still chances that an attacker could still leverage and access various parts of the CI/CD pipeline. And that might come through compromising a developer's workstation, where keys are stored, tokens that are used by the developer in the CI/CD pipeline. Or maybe an attacker finds credentials in like your internal GitHub repo that they can use and inject in. So it's kind of interesting because even if your CI/CD pipeline itself is pretty well controlled and pretty hardened, an attacker can still get in that way. So here is the concept of realms that I mentioned earlier, where you have your corporate realm or corporate environment where your users live. So that's where your workstation fleets are. That's where your productivity tools exist, like Workday and Office 365 and Active Directory. All those different aspects of the environment typically live here in your corporate environment. And then you may have a dev, maybe even a stage or test environment where your developers are taking code projects that they're working on and tweaking them, testing them, working through their projects. And then you've got your production environment where your live sites, live code, live apps live, and also depending on what your company does, maybe there's customer data storage housed here in your production environment. And so you can see quickly how there's so many components and so many technologies and so many interconnections and tech companies that it's important to sort of know how they interconnect and how data flows. And in this case, in this example, one common usage that a lot of companies will do is they'll have jump hosts in place where a certain number of employees are granted access, maybe through an LDAP group or Active Directory group, and to a jump host, and then from the jump host they can get to production in order to ensure that everyone just cannot like access production. And what that looks like might differ. Maybe the jump host is using a different set of credentials. Maybe you have to access the jump host from certain LAN segments, maybe not. It just kind of all depends on what the company's doing, but that's a very common setup. And you see the items in red because an attacker starts to think, well, these are the stated controls, but are there other ways around these controls where I don't have to follow an arduous process if I want to get to production data? And so that's kind of where the thought mindset is on the attacker side. Then you have a concept of secrets management in a lot of tech organizations as well, where there's so many applications that are being built and that exist. And one common solution for management of application secrets is HashiCorp Vault. It's a really good solution that I've seen in terms of like making sure that there's a process and it's difficult. It's much more difficult than having like flat credential files exposed. So it's a pretty good solution. And so your organization might have something like a HashiCorp Vault to manage your credentials, or it may not be managed, where you find credentials in all sorts of places in an environment. And even in environments where application credentials are managed in HashiCorp Vault, it's still possible. You still may find credentials in other places as well, such as on workstations, in your internal Git. Even if an attacker can somehow like leverage keys or tokens, creds that they find to get into part of your CI/CD pipeline, maybe there's a Kubernetes nodes and they can find secrets to get to the master and compromise or own the entire Kubernetes infrastructure. So there's a lot of different directions and places that keys can be stored. And this is also a common aspect of tech environments. So now that we've talked about sort of what common tech stacks and deployments look like, now we're going to jump into some various scenarios around outside in attack paths before we go to internal attack paths. So the first one I'm going to talk through is your credential harvest phishing. And a lot of, or sometimes the thought might cross your mind, well, if we have 2FA, is credential harvest really an issue? And sadly, it still is, depending on the type of 2FA and other controls that are in place. But in a nutshell, I'll say here, using this example, there's tools like EvilJinx 2 that can perform techniques that can get around 2FA phishing, 2FA controls. So in this case, EvilJinx 2 performs what's called man-in-the-middle 2FA phishing, where essentially it clones a target website, and as the victim interacts with and logs into the fake site, what EvilJinx does is it proxies the credentials over to the actual site, and that way it's able to see the username, password, and even loads the script that does a lot of the 2FA pushes. So it's able to intercept username, password, and your 2FA token, saves it off for the attacker. The attacker opens a browser, uses something like edit this cookie, imports it, and now they're inside of your identity as a service portal, like OneLogin, for example. And so once the attacker's inside, they have access to things like email, so they can read email conversations. file access, customer information, or potential sales leads information from Salesforce. And Slack might be really interesting because people oftentimes do post interesting information in Slack. So there's a lot of different things that an attacker can get access to using this method. And here, there's a lot of different ways they could go. They could even go the next step and do internal phishing, which in my mind is actually more dangerous than external phishing, because the emails are actually coming from like your organization's email accounts, which could lead to further compromise. Or maybe in this case, if the objective is to get access to sensitive data or a production application with customer information, and that there's a tile for that inside of Okta or OneLogin, for example, you might, like the attacker may be able to meet their objectives without ever needing to put a shell on a host. And so this attack path becomes very, very relevant in a lot of tech environments because of how integrated things are, and how these employee login portals now give employees access not just to productivity data, but to corporate applications and services, which may have very sensitive data in it. So for that attack path, some blue team considerations would be checking to see if you have the ability to identify compromised tokens. Like, do you have that visibility? Do you have the log sources? And then if so, do you have processes in place for token revocation? Can incident response team do it? Do they have to go to IT to do it? Like, what does that process and workflow look like? And then also another thing to think through is, are there additional protections required for your key applications? So if you have an application inside of the Okta portal or OneLogin portal that gives access to like sensitive or customer data, things like that, then these are valid questions to think about. How, like, once someone's in their Okta, can they just click that portal and just get right into that app? Or do they have to authenticate with a separate set of credentials? Is there another 2FA push? Do they have to be on a certain VPN? Like, all sorts of things to think through, and kind of with the goal being to stretch out the attack path to make it harder and put more roadblocks in place. And then, of course, another one would be device trust. I know Okta for sure has a device trust offering where, using host-based certificates, they use that in addition to your username and 2FA in order to grant access. So that will be something as well that will provide another hurdle for attackers. So another outside-in path is around phishing. And so this is your more traditional phishing approach that's been around for a while, where you send in a payload, and examples of the payload might be a signed and notarized app. That was something on the Mac side that I've been able to play around with and realize that I've been able to actually get red team apps signed and notarized by Apple. So that could be one payload. Macro enabled Office documents, of course. You got to have your macro enabled docs. They work so well. And DMGs with files embedded inside of your DMGs, like just examples. And you may attach those directly to the email. You may have a link where it's hosted elsewhere, but you send your payload, user detonates, and now an attacker has access to the Mac. And most environments, or I'd say in most instances, like you're going to be sandboxed if you're coming through like Office enabled macros that someone ran on their machine. You'll be inside of the app sandbox. So some of these items you won't be able to do there. But if you're using something like a signed and notarized app, then you'll have full access to the system as that user for the most part. And you'll be able to do things like enumerate host information, get some information around what the local IP address is, so what subnet they're sitting on. You could even prompt them for credentials or look for credential files on the system, for like AWS or SSH keys. And long story, you can just continue the same process until you get further enough in the environment where you're able to accomplish your objectives. So some blue team considerations for this scenario. One of them is around parent-child detections in terms of processes on Mac. So thinking about things like Office document spawning shell environments. So it might be bin sh, bin bash, bin zsh, having the detections for those, as well as Office spawning curl or OSA script, Python spawning multiple like shell children, and just sort of thinking through like how an attacker would use Office documents or Python on systems. I call those two out because those are still two very common attack paths on Mac. Another one is user agent string analysis. So one of the payloads I mentioned was assigned a notarized Red Team app that you could use. And I built one myself, and I noticed that by default, the app had a very unique user agent string where it was in this format here in pink, like app name, app version, network version, Darwin version. And unless I had to actually go in to manually modify that in order to change it. So even though that's pretty low-hanging fruit and attackers are likely to change it, or they can change it, I still think it's worth having some visibility into user agents and what some of the least common user agents are, because you still might find some attackers that did not change that in your environment. Also, it's pretty difficult. Like I just put a note here that as much as awesome as it would be to just inventory unique apps that are downloaded and kind of have a baseline and look for patterns, that's awesome, but I think that's pretty difficult to do in most environments. And so that's kind of why I alluded to something more actionable like your parent-child relationship detections or user agent string analysis. Another item to look into for execution on macOS was done by Chris Ross, and he talked about ways to silently install browser extensions. And so an example of the command line might be down at the bottom in turquoise. And so you could search for uses of profile install on Mac hosts. And I would guess you get a lot of hits initially for that, but maybe as you take that and you start whitelisting or anding other things to it, you hopefully eventually can work down to a small subset that just looks for this type of activity in your environment. So that's another consideration that blue teams could have. And then interesting scenario was a Schleyer report from Intego came out earlier this summer, and just Schleier's been around for a while in terms of campaigns that attack Mac. And I kind of drafted up my ideas like of one simple way you could emulate Schleyer in your environment, where you send an email that has a link to a DMG, the user downloads the DMG, and then there's like an image that has instructions telling the user how to basically execute the shell script, which looks like an app based on this icon. User executes it, and then it can download an additional like follow-on command and control or malware from there, like and install it on the system. So that's just one example of, if you kind of wanted to go more of the crimeware type route, like you can look at this approach as well, and you can build a small like controlled scenario like this in your in purple team exercises or in a lab, and just have your EDR, your full security stack available to see what each phase, like what visibility you have at each hop here, and from the visibility you have, what detections you can build from them. So in other words, this will make for a very fine purple team exercise in my opinion. Another thing I wanted to recommend for blue teams, I am a huge fan of Apple's endpoint security framework for macOS. This is, in my mind, it's kind of like the macOS version of Sysmon for Windows, where it's just a good way to look at events and what certain actions look like on the system. And so I typically utilize Patrick Wardle's Process Monitor or Chris Ross's AppMon tool. And essentially what I do is, so I mentioned earlier, I write a fair amount of red team and blue team tools. So for red team tools that I'm writing specifically for macOS, I'll run something like Process Monitor in the back first, and then I'll launch my tool or some technique through my tool, and then I'll stop it and take a look at Process Monitor and see what the actual events were that were seen. And what I what I found so far is that has actually helped me build really solid detections, and in some instances, ways that I thought activity would be tracked were actually different in the event logs. So highly recommend that blue teamers do the same thing. There's a ton of post-exploitation tools out for Mac OS. I've written a couple myself on my GitHub. There's one called Mac Shell that is just a Python-based post-exploitation tool, but it has a macro generator and some post-exploitation modules, so you could play with that. I also wrote Mac Shell Swift, so I took Mac Shell, converted it over to Swift, and added some more stuff to it. And so those make perfect examples of how blue teams could pull down offensive tooling, run Process Monitor or AppMon, run different post-exploitation aspects of those tools or other tools like that, and then develop detections based on those tools. Social engineering being another outside-in attack path. So even though phishing is social engineering, I wanted to have a separate slide for this just because of how I just wanted to emphasize this as an attack path. So most, or I won't say most, but a lot of organizations have externally facing business units, right? It might be inbound sales, it might be customer support, but some type of team that's publicly facing that has an inject point, like whether you call a number or you submit data through a form on a website, but a way to contact that team. And essentially wanting to test out that process and see if an attacker were to try to inject into that process, how would the team hold up? How far could the attack get in the environment? Would incident response team see it? Do they have visibility? And so an example would be, let's say you have an externally facing inbound sales, and so you call the number, you build rapport, just how interested you are in the product or service, some fictitious information about your company. You get contact information, you follow up with some exchange, follow-up emails, so you're continuing to build rapport. And then maybe after several rounds of emails, then you send an email, and maybe the script could be something like, hey, thanks so much for all the help you provided. Very interested in your product or service. Here's an attachment of the proposal that I wanted to send your way that we've talked about in our phone discussion of how I think your product might fit in our environment. Please forgive me, we have a very small team, and the guy that runs our IT shop loves to use macros in order to display these fancy images. So you will have to enable macros, but I really want to send this to you and get your feedback on how we can move forward from here. Like something as simple as that. And then you see what happens. If it's detonated, you get access. And then from there, you move on to your post-exploitation and your objectives. So this makes a very interesting attack path, because sometimes like your systems that might be used by a publicly facing team, such as a customer support team, that might be slightly different email flow than a typical email to an employee. Meaning there may be controls around an email that's sent to an employee that are tighter, perhaps, than emails that are sent over through the ticketing system that might be used for customer support. Like if they're using Zendesk, as an example, there may be some gap in security controls. So this is a really good test, in my opinion, to check out. Now, on the blue team side, some things I recommend is kind of thinking through what security procedures have been laid out for these publicly facing teams. Like, are they aware that they're going to likely be targeted at some point since they're publicly facing? And if so, are there procedures in place? Like, how would the team react if they realize at some point that this is probably an attack, maybe a compromise happened even, like, would they know who to reach out to? And then if they have procedures, how often is the team tested that they're following the security procedures? Like, when does incident response get involved? And then it's a good chance for incident response to see if this attack path happened, like where are the visibility gaps along the way, and how can CERT begin to address those? So these are just some things to think about proactively for that attack path. Of course, another one being external is going to be your public asset discovery. So that's going to happen pretty much at every company anyway. And So externally, things like you may start off, an attacker or red team might start off doing internet registry data, just kind of searching for the company's name or domain names, trying to get ASNs, AS numbers, and then taking those ASNs and getting IP blocks and ranges that belong to that company, which are typically going to be hosted on-prem in a data center by that company. Also doing things like Shodan, census searches, things for like looking for net blocks of what services and applications are running in their IP space, even SSL certs. So that one is a good one for me because you can search for an organization's name in SSL certs and you'll find services and servers that the organization runs but are not on-prem, but are actually hosted by a third party or by a cloud provider. So that's really helpful. Also, cloud asset enumeration, so tools like Cloud Enum or Cloud Brood. I learned about Cloud Enum from Bo Bullock's Breaching the Cloud training. I highly recommend it, really good class. And what's so cool about Cloud Enum is it checks GCP, AWS, and Azure, and it takes a domain as input, and then other like unique things. So if, let's say your organization has a unique product or service or something, you can feed those in, and it uses that as part of like a word list check or brute force methodology to find publicly exposed buckets. So definitely something that red teams and attackers will look at. Also, publicly available files. Power Meta was written by Bo Bullock, really cool as well. And it's a PowerShell script that uses specially crafted searches for Google and Bing to find things that might be of interest, like PDFs or Excel documents, things like that. Searching for exposed secrets in GitHub. So I think we've all heard about like real life scenarios of that recently in the past couple of years. So just these are going to be things that attackers will run as well, looking for credentials in your GitHub repos, and then DNS subdomain brute forcing. So tools like GoBuster, where you might find other interesting hosts owned by your organization. That, like, one example might be, you may find, if your company does like some annual conference each year, you may find a site from a couple years ago from a conference that that they forgot to take down. Maybe there's data there, maybe it's vulnerable, like really interesting data usually when you do subdomain brute forcing. Some blue team considerations. I would recommend proactively assessing what is exposed. So I've been a big proponent of having blue teamers be offensive. Like when I was a blue teamer years ago, that was one of the challenges I had, was sort of jumping into an environment, looking at consoles, jumping into incident response procedures, but not really having the understanding that I needed of the environment and how all the pieces fit together. And I think a good way for blue teamers to do that is by proactively assessing your environment. So even if it's just a little bit of time each week, however it looks like in your organization, I think having blue teamers go out and find this stuff themselves will also help drive their detection strategies going forward. And then also thinking about your runbooks and workflows. If you find an exposure publicly facing, just making sure you know who to contact and in order to get it resolved as soon as possible. Another external attack vector, password sprays. So in this case, I'm talking mostly about spraying your publicly facing login portal, like OneLogin, Okta, Office 365, etc. So there's a lot of different tools that are available for this. There's the spraying toolkit by BiteBleeder. There's MSOL spray by Bo Bullock. I wrote the Okta sprayer. And so there's a lot of different tools you can use. And essentially what it's looking for is trying to find weak passwords. So a common approach will be season and year with a bang, or maybe an @ sign in there, like variations of that. Or even if an organization has a long password policy, like a minimum of 14 or 15 characters, you can still possibly guess a password like the first one, where even though it passes password complexity requirements, it's still by definition could be a guessable password. So it still works, and a lot of times, like, the thought might be, well, even if a password spray works and I have 2FA enabled, like, what does it matter? And going back to the earlier scenario where EvilJinx 2 was able to get around push-based 2FA, sort of a same approach here. If I password spray your publicly facing portal, get an account or two, and then I go log in and trigger a push, everything now relies on the user making the right choice on their phone and either accepting or denying it. And while most employees hopefully would deny it, there still are corner cases where perhaps I sent the push just at the right time where they happen to just log in and they think it's a duplicate and they accept it. Or it happens to be an employee that's not very security conscious and is used to just clicking and not really paying much attention. So there's still a path or a vector where password sprays can still be effective even with 2FA. So blue team considerations around this attack path, recommend kind of thinking through what visibility you have currently into unsuccessful logins on your portals. So if you're using like one login, do you have logs for failed authentication attempts at one login, your one login portal? Also, do you have the ability to correlate activity, and would you be able to know based on your logs like what was successful and what was not successful? Third item I think would be important is familiarity with tools that can do 2FA bypasses. So a couple of those tools here, EvilJinx 2 we mentioned earlier, Cred Sniper, by Mike Felch, Modlishka. These are examples of tools that I think blue teamers would want to take a look at and see how they work under the hood. For example, with EvilJinx 2, going back to how that works, since essentially it's standing up the fake login site, and as the user logs into the login site then proxies or logs in for the user. And so one thing that might appear anomalous is I've done it before where I've used EvilJinx from DigitalOcean. And so the user's login would appear to be coming from a DigitalOcean source, which in the environment that I used it in was very anomalous, was not normal at all. So you could look at things like that, like where are users normally logging in from, and kind of highlight the anomalies in terms of space, IP space. So we talked through external, so now we're going to look at some internal attack paths, assuming that eventually someone's going to get access in the environment. And so some internal attack paths. In this case, I'm going to talk briefly through Active Directory on the next couple slides. So even though most tech environments have very little windows, I still think it's important that defenders be aware of techniques affecting Windows, because you wouldn't want that one or two Windows hosts that get compromised and lead to widespread compromise because you only postured for the Mac side. So from an example here is like from an AD joined host that got compromised, your typical path would be, your AD enumeration, running tools like Bloodhound, looking for paths to domain admin, dumping users, computers, and groups, etc. Maybe even a password spray against your domain controllers. And so this password spray is different from the password spray I mentioned earlier, because the one I mentioned earlier was spraying against your externally facing portals. This one is spraying against, once you're inside, spraying against Active Directory domain controllers themselves. So basically you're dumping AD users, which any authenticated Active Directory employee can do. And you're taking a dump of the users and you're trying one password across all the users. And so domain password spray by Bo Bullock is a good example of that as well. Other things such as port scans. Also be aware that your internal wiki, Jira, knowledge sharing sites like Confluence and SharePoint, those are definitely going to be targeted. There's such a gold mine of information that's available. It could be anything from how to configure your host to get to production, or where the jump hosts live in your environment. Like, it's all sorts of information that is there, maybe even secrets or credentials. So that's a path that's going to most likely be taken, as well as internal Git. And what's interesting about internal Git is there's some comfort level that this enterprise Git is not publicly facing, and so maybe we don't have to have such strong stringent controls over our internal Git. But I would actually argue that it will be targeted just as much as the external one, because there's probably juicier data on your internal Git. And so things like AWS keys, webhooks, SSH keys, like all sorts of good information, tokens, like that could be found in internal Git. Definitely provides a way for attackers to move laterally in the environment. So this is the next slide, just kind of looking at your traditional Active Directory attack path, where the first goal usually is finding, like after you try your normal things like password sprays and curb roasting to try to get access to accounts, you might also try looking for misconfigured servers. So things like Jenkins with the script console exposed, or Apache Tomcat with default creds, or WorkZoog running in debug mode. So looking for things like that result in a quick compromise. And depending on each host, what it's running on, if it's Windows, then you may find that you're able to get cached credentials that way. Or if it's running on Linux, you might find that there's a lot of SSH keys, especially on Jenkins, that you might be able to leverage, maybe even some cloud credentials that are stored there that you could use to look for secrets in the metadata service of your cloud provider, things like that. Another attack path would be password sprays. So you could spray against SSH. So now that you have a set of credentials, you may want to spray against all Macs in the environment or all Linux servers in the environment and just see where those creds can go. Or the same on the Windows side, looking at port 445. And then your typical domain compromise path, where you land on a host where privileged credentials are cached, you dump those credentials, and then you impersonate those credentials to get to domain admin, even create forged tickets. You dump all hashes, you crack them, and then you use the clear text credentials you have in order to pivot. Again, even though I'm speaking mostly of tech environments where most technologies there will not be Windows, just the fact that a lot of them do have some Active Directory still might pose opportunities for some of these paths. So blue team considerations around this internal attack path would be things like what visibility do we have in the port scans or sweeps? And when I say sweep, like I would typically run a check for everything on 8080 as an example. So just one port, but checking that one port across tons of hosts. Like, do we have visibility into those types of recon checks? Do we have any visibility into password sprays against Active Directory or against SSH? Can we see the one-to-many relationship in our logs? Can we search, another idea would be proactively searching your internal knowledge sharing sites just so you know what's there and you can get those things removed and fixed versus like finding out through a compromise. And then also detections for your common AD abuses, such as pass the hash or DC sync, golden or silver ticket generation, etc. So these will make some things that blue teams could consider for this attack path. So going back to CI/CD hosts, what makes them so interesting for the next internal attack path is that they could provide a potential path to production, and it's common at times that you may find misconfigurations on CI/CD hosts themselves, like especially with Jenkins, you may have the script console exposed, you may have the ability for unauthenticated users to run jobs, which you can embed shell scripts into, things like that. And so for CI/CD hosts, like we're going to check for internal Git, looking for secrets. If we get access to workstations, we're going to look for secrets stored on the workstation, as well as in Slack. Maybe somebody has pinned or posted credentials in Slack. So those are paths of going after secrets for CI/CD pipeline. And another interesting thing to do, which would be an interesting test, is you could start on one side of the pipeline where you build a repo and you add this Docker file with an entry like this, just running a basic bash reverse shell. You commit it, have something like Jenkins pick it up, and then try to deploy into dev, stage, prod, etc. Just see how far you can get based on the current controls that are in place. So blue team considerations for those attack paths that I recommend are proactively checking your build and deploy hosts, and that would be both prod and dev. Sometimes there's a perspective that dev hosts aren't as important or staging hosts as prod. Unfortunately, there's still, if you're able to compromise a host that, like a Jenkins host that's dev or stage, and you get credentials off that host, sometimes those credentials also work on prod. So I recommend having all of your CI/CD hosts, both in dev, stage, and prod, all those, like check all those regularly to make sure that they're not running outdated versions, that they're not using common misconfigurations like exposing pages or job execution ability. Things like that. And then also collaboration with product security to build processes and runbooks for your CI/CD compromise. Secrets on devices. So we talked about that a little bit earlier, but in tech environments, since most engineers use Macs, they do their development a lot of times, or do some development from their Mac. Since it's pretty conducive for that. And so as a result, you might find various keys, SSH keys, cloud keys, API keys, application tokens. You might find all sorts of stuff on people's Mac. And those tokens are usually not stored encrypted. And so if an attacker gets access to a Mac and they're not sandboxed, they'll be able to navigate to where those secrets are, copy them off, and leverage them. One tool I wrote as a proof of concept is called SwiftBelt, and it's specifically for Mac OS looking for enumeration, and it has the ability to check for these kinds of keys. So that's a tool that blue teamers you could pull down and play with and run endpoint security against it and see what those behaviors look like. And so other tools that are available that attackers and red teams use is, once you get cloud credentials, well, what do you do with them? So on the AWS side, tools like Weird Owl by Chris Gates or Paku by Rhino Security Labs, they're full-blown like AWS post-exploitation kits where you can take a captured set of keys and do lateral movement, privilege escalation, really cool stuff. I wrote a tool called the AWS Key Triage tool, and it's really just for, you take a set of keys, you run it through the tool, and it does a check to see, hey, are there other secrets and secrets manager or parameter store that I can access using these set of creds, like does more of the enumeration for you for automating enumeration of AWS keys. So these are things that attackers could leverage as well to quickly take a set of keys and be able to do other things with them in the environment. So blue team considerations here. I recommend that good parent-child detections be looked at for host compromises, because again, if I'm going to get secrets off a host, I have to get access to the host. So some of those parent-child detections could come into play. And maybe baseline your most powerful like cloud accounts or service accounts so you know where they're coming from. And if you see anomalies, like that could be something to investigate as well. So in summary, it's really difficult to defend what's not known or understood, and that was a challenge I had as the years I spent on the blue team side was kind of feeling like I was defending a dark room. I knew there was stuff in there, but I didn't know what was in there fully and how it all interconnected. And so I think it's helpful for defenders to do offensive checks just so you know what's in your environment and how things are connected. And it's good to do that because there are stated controls and then there is the reality. And sometimes they're not the same. So it's good to probe those things. A lot of the scenarios I mentioned here will also make for great purple team scenarios where in a controlled environment, you can replay these things, have your detection sources available, and hopefully build high quality detections that way. And it just kind of helps proactively find and uplift the environment before like a real attack or a red team assessment. Other general defensive recommendations, Richie Cyrus, who's over at Apple, he's done some good innovating in this space. He's written some tools around macOS detection. Again, I recommend leveraging the Apple Endpoint Security Framework, getting some base command line detections in place, like what's mentioned here, your network detections, so like your one-to-many, your spraying, your port sweeps, your beaconing, things like that. Active Directory segregation, so ensuring that if your Active Directory environment is compromised, everything else can still stand and may not be compromised. So those are some things to look at. If needed, I'd say don't enable SSH on your fleet, your macOS fleet by default, because that could totally play into an attack path where an attacker gets the remote login credentials and can access any Mac, which could be pretty devastating. And if the IT team is using remote management, I recommend randomizing the password in order to reduce that attack path as well. So thank you everyone for listening. Feel free to reach out in the Discord channel if you have any questions, and we'll see you around.
Hello everyone, thanks for joining to the talk. I am going to share a project that I have created months ago. The project is called Offensive Docker and it is a Docker image with the more useful tools to create an offensive environment to use in a CTF, pentesting or bug bounty. Who I am? I am husband and dad. I have a 1-year-old baby and together with my wife, they motivated me to create this type of project. All the projects require dedication, time to research, tests, and other, and it's important the family support to get them. I have more than 10 years experience in cybersecurity fields, being my expertise on identity and access management. I have participated in different webinars talking about JSON Web Token standard and how to use it to protect APIs. Currently, I am immersed in offensive security. I am learning and practicing pen testing and web hacking. So I decided to practice this knowledge with bug bounty programs where we have real targets to exploit vulnerabilities. How the project was born. When I got into offensive security, I want to have a portable environment to use in different places: desktop, notebook, or virtual private server. So the first requirement was portability. I want to have something like a box and move it into the different environments with the less maintenance and update with the last version. Additionally, it should be configured easily and quickly in all environments used by me to launch security assessments. I was looking for a multi-platform that should work with Windows, Mac, or Linux. Doesn't matter the operating system that I am using. Therefore, if I develop install scripts, it should have a specific logic about operating system to work properly. So, I began to research and analyze what technology can provide me portability and multi-platform. Then, the next requirement was availability. If I create a new server or environment, it should be available in few minutes with all offensive tools to launch a security assessment against my targets easily and quickly. So I began with those requirements. They were specific needs for me, but after talking about the project with more people, I understood that they had the same needs. Then I decided to publish the project and share with the cybersecurity community. Finally, the desire to learn is never lacking in a project. I really want to learn about new technology, acquire more knowledge, and why not share it with the community. So, this is what I am doing today. What is Docker? Before showing the project, it is important to have clear some concepts. Docker is a technology that allows users to easily deploy applications and make portable environments regardless of the operating system. I used that technology to make a portable environment multi-platform and highly available. In such a way, I can create environments easily and quickly to launch security assessments. We can see in the next screen how to work Docker against virtualization. Virtualization allows to create different virtual machines and it uses hypervisor to interact between the physical and virtual machine. We can install different operating systems like as Windows or Linux. For Linux, we have Kali, Parrot, Ubuntu, and others. If I want to move a virtual machine to another environment, I need to copy the full virtual machine. I didn't like it and I felt discomfort because I will always need to have storage the virtual machine to move to other place. So I used Docker because I can create an image with all offensive tools and programming language. An image is built with a Docker file and it has the definitions or structure to build the image. Docker technology uses containers to run an image by Docker engine. I can create multiple containers based on the same image. I can make with a container machines from Hack the Box, with another container make machines from TryHackMe, and with another container make recon processes from my bug bounty programs. By using an image, I can create multiple environments to make different processes, and I can use it in another server or share it with other people. So they can use it without install the tools to offensive tasks. To clarify, Docker has two concepts, image and container. Image has the definition or structure and container when the image is running. What is offensive Docker? Leveraging all the benefits of Docker, I use Ubuntu as a base image and I installed CTF, pentesting, and bug bounty tools, and I make a big image to cover different use cases. Currently, the image has more than 40 tools and programming language. As you know, in different situations, we need to develop our scripts to analyze the targets. We have the next programming language, Go, Node.js, Python, PHP, and Ruby. And I have labeled the offensive tool as port scanning, recon, Git repositories, brute force, operating system enumeration, and others. So I have created an image with the more useful offensive tools to analyze different targets. You can see the link to GitHub repository. Use case. The first case I used like an offensive server. The second case is used like a proxy server. Finally, I can use it like a client for VPN connections. Offensive server. When the containers are running with all offensive tools, can be treated as a server, so I call it offensive server. As you can see in the image, I am showing all the offensive tools installed under the tools directory. Proxy server. In some cases, when we are analyzing targets from any programs, we can detect geographic restrictions. Then, we need to use a proxy server to bypass the restriction. Offensive Docker has installed a proxy server to use it. You can configure a browser or burst suite with the proxy server and access to the targets. The main idea is that the browser, burst suite, and offensive Docker become your best friend to analyze your targets. In the next video, first I identify my public IP address assigned by Internet Service Provider. So I enter to a cloud server with offensive Docker and I launch a new container. Inside the container, I start the proxy server and I monitor the logs to see the traffic. At the left side, I query my public IP address again using the proxy and it shows other IP address. So I can launch my security assessment to avoid geographic restrictions. Client for VPN connections. If we practice on platforms like Hack the Box, TryHackMe, or use a specific VPN provider to avoid geographic restrictions, we need to launch a VPN connection to connect to those platforms. Offensive Docker has installed VPN client and it is ready to start up VPN connections. So I can run a container to hack the box and another container to try hack me. I don't have restrictions to run both containers at the same time. In the next video, first, I list my VPN profile and after that, I launch a new container. Inside the container, I change the current directory to a directory with the VPN profile and I start a VPN connection. If you can see, I am connecting to the Hub the Box platform. At the right side, I enter to the same container with another session and I launch port discovery to a machine. It takes a second and it shows the results. Then I launch another port discovery to a different machine and it shows another results. So you can launch different assessment to have the box machines or another platform using VPN connection. Running offensive Docker. In the next section, I will show you how to run the containers to cover specific functionalities, VPN connections, data persistence, expose services, and mount file systems. VPN connections. When I tried to launch a VPN connection inside the container, it didn't work. I did a bit of troubleshooting, search in different forums, and identify specific necessary parameters to pass when the container is launched. If I don't run the container with the next parameters, VPN connections won't work. The parameters are required for the container to interact with the network interface. Data persistence. The data inside the container is lost when I delete the container. That is not a good idea for us. As cybersecurity professionals, we need to store all information about our targets. Docker has a parameter to mount a local directory from my server or computer with a directory inside the container. We can store all information in the directory inside the container, remove the container, and all information will be saved in our server or computer. We don't go to lose the information. Expose services. If we go to expose any services inside the container, there is a parameter to enable the access from outside of the container. If we don't pass the parameter, nobody can connect to the services. For instance, the parameter is useful if we want to launch a web server inside the container to provide any information. Mount file system. In some cases, we have some target with resources shared, and for easy access, we can create a local mount to access and work with the information shared. If we don't pass the parameter privilege, it shows an error and we can mount resources shared. Offensive Docker Custom. Offensive Docker has a set of tools with default configurations, but there are tools that require additional configurations to exploit all functionalities and get bad results. Due to this, a customization is required and I have worked in a process to achieve it. At this moment, this process works for me, but I don't discard other options. You can see the link to GitHub repository. We go to see custom settings, process to follow, and example. Custom settings. Some tools require credentials like IP keys or tokens to retrieve more information from different sources. For instance, AMAS, Find Domain, or Subfinder can retrieve more subdomains in a scanning against a scanning with the file configurations. I told you that the data doesn't persist on the container, so all command history is lost when I delete a container, And for us, the command history is important because if we forget an important command, we can search on the history. So I have identified the process to store and maintain the history command via customization. Alias or function environment can help us to do our job quicker. A good tip is to generate an alias or function environment to work more comfortable when we launch the offensive tools. We can add them to the offensive Docker via customization. Process to follow. How did I resolve it? I started using offensive Docker as my base image, and I have fed it with AP keys or tokens, aliases, functions, and setup paths to build a new image called offensive Docker custom. Of course, the new image is private because it contains personal credentials. I don't suggest sharing the custom image. Example, I create a new Docker file. Docker file has the definitions or instructions to build a Docker image. If you can see the image, I have declared WordPress scan token to scan WordPress sites, Amazon Web Service access token to retrieve information from public S3 buckets if there is a misconfiguration, his file to store the command history, find domain tokens, aliases, and other. Finally, the next step is to build the image, and we have an offensive Docker custom image. Following this process, I have customized the offensive Docker with my personal settings to get better results in my security assessments. VPS full automation. VPS means Virtual Private Server. I didn't only work with the Docker customization by a specific process. If there is anything that I like, is the automation. I don't like to do manual processes or do processes more than twice. I like to run just a command, and that is what this project is all about. In some cases, when we find a big target on bug bounty programs, the recon process can take some hours until finish, and we don't want to have to turn off the computer, so the option is to run a VPS. I work on how to automate the VPS creation and configuration. We just access to the VPS and it is ready to launch the security assessments. The steps to launch a VPS are server creation, server setup, and finally server access. The steps 1 and 2 are launched from just a command, and I have called it full automation. You can see the link to GitHub repository. Full automation. It has 2 steps. The first is server creation. For this step, I have used Terraform. Terraform is a tool to create infrastructure as code. By Terraform, I can provision infrastructure in some cloud providers, but I have chosen DigitalOcean or Google Cloud Platform. Also, I can pass my personal SSH key to access securely without username and password. But the server is not ready to launch my security assessments because it hasn't the offensive Docker. The second step is server setup. For this step, I have used Ansible. Ansible can configure the server status by playbooks. In the playbooks, I have defined how the server should be. For instance, I install Docker, download GitHub repositories, download offensive Docker image from Docker Hub, and other. Ansible use the SSH key defined in the first step and connect to the server to deploy the playbooks. In Ansible Playbook, the main task is install Docker and download offensive Docker from Docker Hub. Additionally, I have configured fail to ban service. It is a service to block non-authorized accesses. After I deploy a server, I have seen non-authorized accesses in the logs with SSH connections. Offensive Docker is a public image from Docker Hub and you can use it. Now I am going to show the full automation video. First, I initialize Terraform and then I run Terraform apply to create and configure the server. For this video, I am using DigitalOcean. I am going to advance the video in some parts. After a few seconds, the server was created and the next step is configure the server. This option is made by Ansible, and Ansible has many tasks. For instance, update and install package, install Docker, download offensive Docker image. This part is the most important. So I am tuning the shell to the server, and at the last step is show the public IP address. With this public IP address, I can access to the server and launch my security assessments. The last step is server access. We use any SSH client to connect to the server. Don't forget to use the SSH key used in the first step. After to follow all that steps, let's start the game. We can launch subdomain discovery, port scanning, search directory, and other to retrieve as much information as possible about our targets. Finally, with the public IP address, I can access to the server with the credential, and inside the server, I can launch the container with offensive Docker. That is all. Demo. Let's go to the demo and show how offensive Docker works. As you can see in the screen, possibly go wrong. Demo time. In the next demo, I showed you different functionalities about offensive Docker. I am going to create a demo session and I am initialize my Terraform backend, and the next command is Terraform apply to create the resource. For us is the VPS. After a minute, the server is created and the server is configured with offensive Docker. That's the most important steps to the automation. In the meantime, I am going to open another Windows to check the offensive Docker locally. I told you in the talk that a good tip is use alias, right? I have created different functions environment to launch the offensive Docker. This is for offensive function. I have another function for HubDevOps platform and another function for GrayHat platform, right? If you can see in the next functions, I have a history in the same path to store all command histories launched inside the Docker, right? I don't lose the command history information, and I pass the parameter to mount a local directory inside the container when I launch the container, right? I pass this directory to mount inside the Docker, right? In the next folder. Okay, let me check the full automation. Okay, the server was created, right? The server was created, and now the server is being configured by Ansible, right? Now the fail to ban is being installed. Okay, go to local session. I launch a hack the box function to launch a container called RTV for Reptile Village. I am inside the container. If I list the directories, I can see offensive directory and tools directory. Let me check the offensive directory. Offensive directory has two resource folder machines and my profile VPN, right? Inside the container, I have an alias to launch the VPN, right? If I enter VPN HTTP, the VPN start. If you can see, I am connecting to the Hack the Box VPN inside the container, right? This is my profile to Hack the Box. Now I am opening another pane. I need to access to the same container, right? How I access to the same container? I have another function called access, where I pass the name of the container that I launched. The name was RTV, so now I access with this name, Reptile Village, sorry. I am in the same container where I am connected to Hack the Box platform. Now I am scanning for a specific machine. I am going to do a port scanning for this machine and see what ports are open. Right, we can see 2 port opens, 21 for FTP server and 80 for HTTP server. Now, are you questioning about how to access to HTTP connection inside the Docker to analyze what website is here, right? We need to into graphic browser to see more comfortable the information, right? The solution that I thought is start the proxy inside the container, and in my browser I have a Foxy proxy that is a good plugin to use different proxies. I have different proxies configuration or profile for different proxies, and now I am going to launch my HTTP connection to the machine. So I have access to the server by my browser using the internal proxy in the container. That is the option that I am using to access to HTTP information or HTTP sites by the container and the container is connecting to the VPN for Hack the Box, right? You can see the websites to analyze this information by this way. Okay, but you configured the proxy in the browser, but also you can configure the proxy in Bursuite. For instance, you can use a Bur proxy in Bur. You can configure the proxy localhost. This is the internal port. Okay, intercept is off. Now I go to open again the site, but the traffic is by proxy in Bur, and Bur is using the proxy in container, right? Using this way, I can connect in the browser using Bur using container, and container connecting to the VPN on Hack the Box, or I can use another VPN, for instance, try HackMe, or if you use a specific VPN provider, you can use this way to connect to different traffic, right? That is the option that I can provide to this use case, right? Now let me check the full automation option. The offensive Docker image is being downloading by Ansible using the playbook, and we can check another use case in the local. Okay, I can use another tool like as Deer Search or Deerbuster, or another tool to use to search directories, right? Inside the Docker, if you see the tools in tools directories, there are the different categories that I have labeled to the tools, right? We can see for recon, Deer Search, okay. Now using Deer Search with a basic the dictionary, I am fusing the site to search by high directories. If you can see, I can access for a directory that GitHub. Okay, go to the browser, paste the directory, and I can access to this information, right? That is the option that I am providing with Offensive Docker. You have some tools to do different process and try different platforms to improve your skill with cybersecurity. You don't need to install all tools because it is a hard effort. You can lose time install the tools and fix problems or do any troubleshooting by the issue installing a specific version of tool. But using Offensive Docker, you can launch different environments to analyze different targets, right? Let me check the full automation. Now the full automation is finished. The public IP address is shown in the screen, And the next step is access to the server with the IP address. Okay, now I am in the server in the DigitalOcean, right? If I check the image, I can see offensive Docker image. Now I need to launch a container. Okay, I am in the Docker in the VPS, right? Now inside the Docker I can launch AMAS for a specific domain, for instance hackerone.com. And I can search for subdomain for this domain, or I can launch Subfinder or another tool that Offensive Docker provide, right? That is the main objective, that you can use Offensive Docker locally or in a VPS, and you can launch different tools. I can stop AMAS and I can launch Finder. And you will see the different domains, right? Now you can start the proxy, right? You can, in your browser, if you do a search about your public IP address assigned by internet service provider, this is my public IP address, but now I am going to configure the proxy. This is the public IP address assigned by DigitalOcean to my VPS. Now if I check again, I am using the public IP address by VPS server, right? With this option we can avoid geographic restriction when we need to access to specific targets. In bug bounty programs there are targets to specific countries or specific traffic from any source, and you can bypass this restriction by using a proxy. This is some options to use Offensive Docker, right? So if you don't need more the infrastructure on cloud, you can destroy all resource to don't incur in high cost, because if you have a server turned on, it has a cost. You can destroy all infrastructure with the Terraform destroy, the server is removed, right? When this option you saw the full automation option and use the server locally accessing or analyzing hack the box matching. To finish, Offensive Docker reviews. I don't know if you see the videos from XSSRat. He's a bug bounty hunter and he did a review of my Offensive Docker on YouTube. He called the video "Stop wasting your time installing tools and start using this Docker image." Integrity is a bug bounty platform and it suggested Offensive Docker 2 weeks ago. Kitploy, and Hacking Night blogs have suggested offensive Docker in different articles. That is a good reward for the project. Thanks for your time. I hope that you have enjoyed the talk and the project. The project is open source and you can contribute to it by pull requests. If you like the project, give it a star for it and subscribe to the new release. If you want to see the slides again, you can see the link to the presentation.
Hi all, welcome to the session about the dark side of cloud configurations. Today we're going to talk about a cloud configuration and cloud security. But before, a little bit about myself. My name is Vladis Sandler, I'm 32 years plus one. I'm the co-founder and the CEO of Lightspin, a next generation cloud security platform. I have more than 30 years of experience in security, both red team and blue team. And in the last 6 years, I invested a lot of time in learning offensive side of cloud security, and that's exactly what we are going to talk about today. So let's try to understand the problem before we go drill down. So the problem is not a new one, it's the misconfigurations problem. But what is interesting about this problem is the approach. This specific problem has two different approaches. The first one is a Fortune 500 companies which actually continue to do an M&A process, like PayPal, for example, which is an on-premise company, but during the M&A process, they acquire a cloud-based company. Now, it's interesting because they don't always have an ability to do a good due diligence on the risk level of the cloud environment, which is going to be connected to the on-premise one. From the other side, we see companies which are part of the digital transformation process are actually migrate to cloud or create their products on the cloud from day one, like Hulu, Netflix, Monday.com, and more. Now pay attention. Once you move to single cloud like Amazon, only on Amazon we have more than 2,500 different IAM policies. So how should I handle a scale? What should I do when we are moving to Azure and Google Cloud also and become to be a multi-cloud environment? On some point, we even implement a Kubernetes and we become to be a multi-cloud service mesh. So our environments are distributed between the multi-cloud and the hybrid cloud. We always have a starvation for experts. And there is no holistic solution that can help us to manage this environment. And in the end of the day, everyone in the organization can do deployment. So we come to the situation of misconfiguration. But bigger problem is not the misconfigurations, it's the exploitation of them, something that we call configuration vulnerabilities. And that's what I want to show you today. But before, a fun fact. All the companies that were breached last year were compliant. Now, it's interesting because it means compliance is not good enough. So even if you are going to use an open source tool or some vendors are going to do benchmark analysis and compliance, you actually now can understand the checklist analysis to check if you're standing in regulation or not. It's not good enough. And even more, using that we can understand a couple of things. If in application layer we have data and we talk about application security, which brings us to application vulnerabilities like SQL injection, and if in infrastructure layer we have the network and we talk about network security and we have network vulnerabilities like R poisoning, in cloud everything done by infrastructure as a code. So we talk about configurations and configuration security, which brings us to new domain called configuration vulnerabilities. And in this case, we are going to exploit attacks like privilege escalation via EC2 instance, run instances permission that we're going to present today. So before, let's try to understand which kind of security configuration issues do we have. Basically, there is three kinds of them. The first one is a misconfiguration, a human error in configurations maybe. The most famous one and classical one can be the example below. We have an EC2 instance which is exposed to the internet behind a load balancer. But by mistake, the DevOps exposed the same EC2 instance directly to the internet by providing a public IP. Now, that means that the attacker actually can communicate directly with this EC2 instance. Another great example for security configuration issue is a weak configurations. I mean, the best practice say use TLS 1.3, but we did a bad practice and we are using SSL version 3 or TLS version 1, which are vulnerable to poodle attack. The last kind is risky default settings. For example, we have a keeper which is in use by all of these EC2 instances that you see here, connected to them. Which means once you compromise one EC2 instance, you can compromise all of them. And it's actually a problem. I know that management of keepers it can be really difficult and complicated, but if the attacker can compromise all of your servers, it will be probably much more bigger problem. So probably we should do that. So configuration vulnerability, it's one of the type mentioned above, or a couple of them, that can be exploited by the attacker and applied in any attack tactic from privilege escalation, lateral movement, persistency, and more. So now I think it's a good time to see a use case. Let's talk today about a privilege escalation via EC2 run instances permission. If you're not familiar with run instances permission, it actually allowed us to launch a new machines on Amazon. So in our use case, we have a classical environment. In this environment, we have the EC2 instant Jambox server, which the DevOps actually use the internal employees in order to connect the environment and manage the VPC. As you can see, this specific VPC has more. It has RDS and another EC2 instance, which exposed to the internet on SSH, and it actually has two problematic issues. The first one, its keeper was exposed to a public GitHub. The second problem is that this specific server has three permissions: run instances, pass roles, and list roles. And that's exactly what the attacker is going to exploit. So, our attacker browsing to the public GitHub and obtain the exposed SSH keeper, using which it's going to connect actually the first EC2 instance. Since the attacker actually has a list role attached to the machine, the attacker can use it to discover which kind of roles we have in this environment, and that's how the attacker discovered the maintenance role, an administrative role. Using the run instances and pass role, the attacker can create a new EC2 instance and attach for that the maintenance role that discovered before. And since the attacker actually has SSH keeper that he discovered in the public GitHub, it can use it during the EC2 launching process and use it again to configure the machine with that. Which means now using a lateral movement, the attacker can access the new machine, which has an administrative role, and actually compromise the VPC. So now I think it can be a great moment and do some demo. So let's see how does it look. So great. Our attacker actually authenticated to our EC2 machine just because it has the SSH key. And from this moment, the attacker will start to do the due diligence and the discovery process. The first step, it will be go to the metadata API of the machine and get more information about the machine, including extract the dynamic key, the temporary token called STS. We have here the access key, the secret access key, and the token. Don't worry, I took care of it before, so we have it in our environment variables, so we don't need to waste time on that on this moment. In the next step, the attacker should understand which kind of the permission this specific machine has. So we can use classical open source solutions like Enumerate IAM, which is going to do a brute force attack and help us to answer this question. Once we execute the tool, it will start to do a permission brute force attack and will try to enumerate and expose all the attached roles to this specific machine. And as you can see here, this machine has several interesting permissions, but the most interesting is list roles, which means we can stop the enumeration attack and we can start use the role. Of course, the machine has more and we can continue a brute force or just trying by ourselves If, for example, we will run the following command, we can see, as we saw before, there is a get caller identity, so we can see that this machine use MGMT role. We can try to execute another command like s3 bucket ls and see that specifically there is no bucket permissions attached to this machine. But as I said before, we want to use the AWS IAM list roles. So once we execute this command, we can map all the existing roles in the environment, our Amazon environment. So next step will be to filter this information using JQ so we can map better visibility. And now we can see that there is a maintenance role that can be attached to EC2 instances. In the next step, we are going to use a run instances command and launch a new machine in our environment. Sorry for that. A new machine in our environment. And the machine successfully created. I guess you want to know what exactly I did. So I browsed again to the metadata API and extract from them image ID, instance type, our subnet ID and group ID, and I know the maintain roles that I'm going to attach. About the key, I use the same key pairs that I discovered on the public GitHub. So now the attacker will take the new private IP address which was created and going to do a lateral movement. Great. So we authenticated to the new machine, and once we run the get caller identity command, as you can see, we actually now using a maintenance role, which means we did a privilege escalation in the environment, and actually now we have an ability, which is an administrative role. So now we have an ability to take control and compromise the VPC, the whole VPC. So what actually we can learn from this use case? It's really great use case, because from this moment we can understand a couple of things. First, don't rely on your cloud providers. I mean, they don't really responsible for permission and configuration. It's something under your responsibility, which means you should take care that you did it correct. Compliance is not enough. We need real security. We need to do best practice cloud security in order to handle the problems. So in order to do that, my approach is view your cloud stack from an attacker's perspective. Once you do that, you can better understand how does the attacker see your environment and how that attacker going to exploit different misconfigurations or risky over permissive in order to cause a damage to your environment, which allows better estimate the risk of the environment, better estimate the priority to take care of the different problems, and of course, better prepare a mitigation plan, both open source, vendors, or just best practices that we should do inside the environment. And of course, be proactive. Prevent the data breach at the configuration stage, which means both on the CI/CD pipeline, we can do a lot of analysis, static configuration analysis before if we use Terraform, for example, and both once the deployment happens. We can analyze the environment, we can find misconfigurations, and we can take care of them before something happens. Because if we will wait until something will happen and we will detect the attacker in real time, it's too late. The meaning is the attacker is in our environment and we don't really want to go there. So that's the most important point on our approach. Great. So if you have more questions, feel free to contact me and subscribe our LinkedIn page. And for anything else you want, feel free to contact me. Thank you for your time. It was nice to meet you guys.
Hello, thanks for joining. I'm Brent White.
And I'm Tim Roberts.
And today we're going to go over some common methods that we use to obtain access to buildings.
Who are these guys? Well, like I said, I'm Tim Roberts. I work with Dark Wolf Solutions. You can find me on Twitter at ZanchinHacks, my Twitter handle under my name there. Also, wehackpeople.com. That's Brent and I's site. This is a repository of a lot of the talks we've done over the years, our presentations. Also, we do a pretty active blog on there with covert entry and social engineering. Also, some red team tips and tricks.
I'm Brent White. I am a senior security consultant at NTT Security. So one of the most common misconceptions, especially from the media, is when you hear the word hacker, you automatically think of someone that is going to rob you in the parking lot and steal your baby and all of these things. So obviously there are those bad hackers out there, but I want to point out, like Tim and myself, we are good hackers, or white hat, or ethical hackers, whatever title you want to put on it. The whole point is we do this to find vulnerabilities to report to clients to help them strengthen their overall security posture.
And there's also, I know a lot of people get kind of reserved when they hear penetration assessment or penetration test on my network or against my building or something. It's just to reassure you that this is done to help you. It's not done to ding you. It's not like an audit where we're like, hey, we got you. It is done in collaboration with your security team and just to help you understand kind of where you stand, especially when it comes to real world threats.
So one thing I want to point out is talking about the word unauthorized. So whenever we perform these assessments, I want to be very clear that we were employed or tasked by the client to do these assessments. They are very well of what's going on. We've had all the legal paperwork signed, and nothing that we are doing is illegal. And we do not condone that you any illegal activity at all. So if you are going to utilize any of these tools or techniques, please make sure that you have the proper authorization.
So what are we going to cover? We're going to cover a few different things. If you've seen any of our talks in the past, we might touch on some similar things, but a lot of this will be focused on covert physical security assessments. So what does that mean? It means that we take on an adversarial role where we attempt to gain access to your facility, data center, sensitive areas. This could include getting access to your systems and things like that, or it could just mean, hey, did you get into the server room and we take a picture of the server or your core switch, or maybe you've put a post-it note on a system that you want us to try to take out of the building or something like that. But its primary focus is to try to bypass physical security access controls, electronic access controls, and then also this often includes social engineering. So doing face-to-face engagements to try to gain access or convince someone to give us access to their system, let us into an area, anything like that.
Yeah, this is basically anything that we can utilize to gain access and get out without people even realizing that an attack happened.
And as a part of this, we do a lot of reconnaissance. So, we'll start off doing like remote reconnaissance, like pretexting. That's harvesting like OSINT, just open source intelligence. This may even include if it's like a red team kind of approach where you're using multiple attack vectors. It's not just focused on a covert physical security assessment or physical site survey or anything like that. It may include vishing or phishing and those kind of remote social engineering attempts. So there are,
go ahead, Tim.
no worries. So there are a few different ways we do that. I mentioned some of the OSINT stuff. There's a lot of tricks out there, and Google Dorks I think is probably one of the things that I use the most. There's a lot of tools out there, the Harvester, a bunch of OSINT tools, but utilizing this, you're able to not only try to gather information and enumerate usernames or email addresses or anything like that, but you can also look at Google Street View. Google Street View has come in handy so many times. for identifying badge readers, to seeing where camera placement is, to seeing where points of entry and exit are. Google Street View is amazing. I'll just leave it at that.
It's very handy. So, kind of adding on to that with passive reconnaissance. So, there are ways to find out before you even go what type of wireless technology they are using, webcams, and pretty much anything that might give you an advantage for your guys. If you're looking for current users or usernames, or if you find cameras internally, it might give you an idea of the building's layout. You'll also obtain information such as the culture, the dress, potentially, any information that could be used for where badge readers are, what badge reading technology they're using, so you can configure your badge cloner properly. There's a lot of information that could be utilized from this.
Yeah, then even looking at some of the metadata on these documents that you can able to pull. So let's say you're using some Google Docs to find some PDFs, you pull those down, and then looking at the metadata on it. Oftentimes you'll find things like usernames and such, which is pretty fascinating. Using tools like PwnDB, or there's a lot of other tools out there that'll comb the dark web and see for any kind of previously compromised doxing or any kind of like usernames and passwords that have been kind of released out in the clear. So a lot of people say, well, those passwords, that was done like several years ago. That's a good point. However, those usernames probably didn't change. So unless there's a big turnover, that's still pretty handy, even in enumerating usernames.
Yeah, and even maybe to take that to a deeper, even more creepy level, which unfortunately we can use in manipulation for social engineering attacks, is if we find a user that we are targeting and part of their password happens to be the name of a favorite pet or the name of a favorite sports team, for example, now we know a bit more about them and we can attempt to leverage that.
Yeah, and I've even used some phishing campaigns based off of finding some of these passwords and stuff, just to say, hey, so there was a breach and blah, blah, and then I'll even tell them that old password, or just to confirm or something. We just want to make sure that you changed your password, and then provide them a password to change it to, explaining, hey, we have just rolled out some a new password policy, and we just want to confirm that the complexity requirements are kind of across the board and on an enterprise level. So just to confirm that, could I have you change your password to winter 2020 exclamation point? And that has worked too many times. It's pretty embarrassing.
So we mentioned Google Dorks. This is just sort of a quick snapshot. We've got this slide, and the next are some pretty common Google Dorks that are very beneficial to us. So if you want to go ahead and go to the next one too. So, this helps when you're looking, we mentioned network cameras. With these Google Dorks, it helps to sort of pin those things down a bit. There are also web services out there such as Showdown, where you can look for IoT connected devices or get a better footprint of something that might be connected for your target. There's a lot of resources, exploitdb.com. Also, Johnny Long, he's written several books regarding this. And luckily, there are also tools that help to automate these Google Dork searches.
So something we see a lot of is people will post pictures online, like they're excited about a new job, or maybe it's just kind of on accident when they take a picture and their keys are laying on a desk, or they're attached to the lanyard that's got their badge. It's bad enough that you're posting a picture of your badge, your employee badge online, or sometimes I'll see marketing photos, especially corporate events or something, or everybody's standing side by side smiling, and they're talking about employee culture is this, or they're playing some foosball or something like that, and they've got their lanyard around their neck. Then you see both a key and what the badge looks like. A lot of people don't know this, but when you look at those keys, you can sometimes, we know, Brent and I know people that can see a key and guess the bidding on it. So the depth of the teeth on the key is a certain number. And we know people that can just look at that and take a glimpse of it, guess it, and then go home and then type in something and print off that exact key. It's pretty crazy and incredible. But there are applications that will do that same thing.
And you see this a lot too at places that are a bit more secure, where it requires their credentials for a card as well as a physical key, especially at banks. So banks often will host a lot of things trying to get in new customers. And so they, as Tim mentioned, they'll have the company events where they're all hanging out, and you'll see not only their badge hanging from their neck, but the key there as well. So there's plenty of opportunity for those with malicious intent.
Yeah, like I was saying, like some of the applications you can get, Snappy Decoder is one of them. That's kind of an example, little screenshot of that. And then also, if you're interested in this stuff, our buddies at Red Team Alliance, they do an amazing job of discussing this kind of thing in depth. But yeah, check it out. Check out key bidding.
So these are a few quick examples. We talked about Street View. If you're trying to do some planning and things before you go, which if you've done any of these types of assessments, you will quickly realize that pre-planning is a must. You don't want to just show up day one and not know anything about where you are going. So Street View, you can see that from across the street, the Door King access control system. So if this particular example, this is not from a target. It's just a quick sample that we pulled up to quickly identify that this particular location utilizes Door King. And if you're familiar with any of that, there's a master key floating around. There's also a few other types of attacks that can be performed against that to, help yourself gain access as needed.
I mentioned earlier about badges. This was actually something that I pulled off of LinkedIn. One of the marketing directors for this company had posted a few pictures of employees just hanging out, and I was able to just kind of look at that. And I did this right before, just to show how quickly you can just kind of look at a badge and then make something that kind of looks like it. This I covered it up obvious reasons, but I just kind of made this more as a joke, but just to show a proof of concept to say, hey, don't do this. Don't post badges. If you're working for HR, if you're working for marketing, and you're doing this, this is very important to be aware that there are hackers out there. And I know I've heard tales of people that just sit there and they harvest badges off of social media, and they'll have a big directory of just badges that they found to be able to print off fake badges on the fly.
Same goes for your personal credit cards as well. So there are several tools that can be used for this. And one of the things I want to point out to you, everything that we use, every bypass tool, every script, everything that we use, we make sure it's something that's publicly available. And we do this to drive the point home that, this isn't something that just someone with a locksmithing license or some special approved access can do. These are tools that basically anyone can obtain and utilize against these vulnerable targets. This is a picture of a Wi-Fi pineapple that we placed on top of a drone, and it works surprisingly well.
Yeah, and just make sure that you're obeying. Like if you're using a drone in your surveillance, I know a lot of people are kind of doing this. And drone technology is all over the place, but make sure you're obeying drone laws. That your client may not even know that. So if you just show up one time and then you're flying a drone around, You want to make sure that you're looking at the local laws and everything, and not get in trouble for that. So, oh, real quick, a good way to protect against the drone stuff is to tint your windows, on your building in sensitive areas. A lot of people don't do that. So, having blinds or tinted windows or something like that. There are highly secure areas with Faraday cages and things on their roofs to prevent that drones from landing on top of them. But, as far as, some people will fly a drone around your building, especially on off hours where I've seen buildings where they leave the lights on at night, or the cleaning crew leaves the lights on, and they can just use that drone to fly around, and basically look around and see, and there's high enough definition cameras out there to sometimes pull information, especially if you don't have a proper clean desk policy, or people aren't really adhering to that, and they're leaving sensitive information on their desk or their cubicles, and that's facing the window. You'd be surprised at how much you can utilize something like a drone to do something like that.
Yeah, and in higher security places too, they do have jamming technology, or technology that scans for the frequency of common drones as well. So let's go into more active reconnaissance and surveillance. So I want to point out again some really cheap technologies that are available. This is pretty well known, the ink pen camera. It's very cheap, but it's actually pretty useful. One thing I do want to point out is if you are going to utilize something like this, there's a few things to consider. One, you need to understand the laws of recording people against their knowledge. Two, if it's a more secure area, you need to learn how to change the appearance of this technology. People that are skilled in this will quickly spot these types of cheap gadgets. And on the next slide, you'll see too a very cheap video camera inside of a cigarette lighter. I think at the time I paid $5 or $6 for this on eBay. I don't know if you can still find them there, maybe. Same type of thing. This is a bit more inconspicuous, but again, you need to learn how to change the concealment of these technologies if you are buying them, in mass. It's something else I want to point out. Don't ever use these glass cameras. They're not convincing. They're super thick. You'll be spotted a mile away, and it's the only reason I would suggest that you use it is if you are testing incident response and you're trying to see if people are paying attention and you're trying to be caught, which is something we will do sometimes.
So it's really important that you're blending in. We mentioned before, you can get online and kind of look at pictures from a target location or facility and see, the dress code, or, see if there's some construction, even when you're driving by or something like that, looking to see if there's a busy area, what is the dress code? What is the policy? Is there construction going on in the building? Is there construction going on across the building? There's been a couple different times when Brent and I had worked together and done these projects where there's been a real busy downtown area, and it's super congested, and a lot of construction workers going in and out. So dressing up like a construction worker is super handy for doing some surveillance from, let's say, across the street, if it's there at the facility. One of the things that we like to call the covert clipboard, and you'll see it in use in one of these videos here in a little bit. But that's what I've got in my hand there, and it's a badge cloner. In this picture with Brent on the left, he's actually entering a elevator. That's me behind him taking the picture. And he's got a BOS cloner in that laptop bag. If you're not familiar with that, it's kind of a longer range badge cloner. Really amazing stuff. But Brent's, when you're tight in an elevator with a bunch of people and they've got their badges dangling at their sides, it's pretty easy to clone that badge just from standing in the elevator. You don't have to bump into anybody or anything like that, like Mr. Robot. You can be a significant amount of distance within that elevator and still gather those badges.
And that particular image, through our reconnaissance, obviously we figured out the dress code and what was needed to blend in. And when we travel, we have to take quite a few options with us so that we are prepared for most situations. So on top of blending in, on my very first covert assessment against a hospital, walking around and quickly found out no one paid attention to anything. So sitting in the waiting room, and I had a very large alpha antenna to do wireless testing, and I figured someone would at least come out and ask me what was going on because it looked very out of place and no one did. Adding to that, after walking around the entire facility, very sensitive areas, talking about emergency room areas, I got close enough to where the babies are, but I did not enter that area just because I did not want to take a chance that if I had some sort of illness or something I wasn't aware of, it wasn't worth the risk to me to potentially pass that on to them. So after being there for a bit, I started realizing that different people were wearing different kinds of scrubs. And I realized that the sanitation crew, they were wearing maroon and so on. And I walked around the corner of a part that I hadn't been to yet, and there was a gift shop there. And this is an actual picture from that gift shop. They were selling all of the scrubs that were being used in that hospital. So it doesn't take a genius to guess what I did next. So,
What's funny too is, like, speaking of gift shops, a while back there was this big convention that I was doing an assessment for, and they sold the lanyards. And then a lot of times Brent and I will stay at hotels and use their office area, or we'll go to like a something like a Kinko's or a print shop or something, if we have to. But to be able to just kind of play arts and crafts and come up with a badge on the fly just because they sell like lanyards and the plastic badge holders or something like that, it's kind of ridiculous. If something just resembles, it doesn't even have to be perfect, because a lot of times people aren't going to sit there and stare at your badge. But we encourage, of course, you to go as much detail as possible and make it as accurate as possible, especially if you can get a functioning badge and capture that and clone it. That's of course what we would encourage. But when you can't do that, just a simple, something that resembles it is pretty effective. So no key required. We do a lot of bypassing. Lock picking. We'll do lock picking sometimes, but I would not say that is something that we do. I wouldn't even say 50% of the time. I don't know. What would you say, Brent? Like, I don't know, 10, 20%?
Well, yeah. So there are times, obviously, where we do utilize lock picking, and I know that in the past, usually when we are sort of in a hurry or trying to obtain access, we take the path of least resistance. We do encounter locked doors, and sometimes we will see a quicker option that doesn't require us to pick the lock, so we'll go that route. But I think it really sort of depends on the approach that you take. But I know for us, we've had quite a few pretty successful engagements where we haven't even touched a lock at all. So,
yeah, I think the thing that has helped with lock picking the most is, for me at least, is getting into like the fire escape area. Because during production hours, oftentimes they don't have those alarms active on the fire escape, but they also don't have. Sometimes they don't have like badge, like they may have some badge readers on there, but even with that, you can still oftentimes bypass that by picking the lock. There's also been times where I've picked the lock on a server room. They've had like two-factor authentication on there, like a biometric reader or a PIN and badge. Access control, and then you can bypass that just by picking a really poorly placed tumbler lock that is on there that they hadn't considered before, investing in some expensive electronic access control stuff. Yep. This is a big bag up here at the top left of lock picks. we don't encourage you to carry this big old thing of lockpicks around with you and the Leatherman and all that stuff. It's handy to have, especially in your bag, depending on the scope of the assessment. But oftentimes we'll do something light. This is a picture of my cell phone case, and I've just got these small picks, some shims in there that I just keep in there. In addition to that, I'll have a diagnostics reader for RFID, like badge readers, that just to tell. So if I'm doing any kind of like reconnaissance and I want to know, is it a low frequency or high frequency badge reader, and then contact Brent and be like, hey man, flash that prox mark to low frequency. It's easy to kind of do on the fly. Having something like a hall pass, which is a little card shaped shove knife that you can kind of keep in your wallet. There's a lot of different options like that.
Yeah, and so moving on to that, we've got one of the things that I like to put a lot of research and time into is taking these covert tools or these bypass tools and making them in such a way where I can conceal them, and even wearing normal street clothes, you can't tell that I've got a full set of bypass tools hidden on me. This is one tool that I've made. You can read more about it on wehackpeople.com. Basically, it gives a full breakdown. So on the bottom right, you can see these handful of tools. You've got these a few different master keys, some jigglers, Adams Wright bypass tools, some decoders, and so on, a few picks. All of those things could get pretty jumbled together in certain bags. So I was able to modify them through some machining techniques and add them to this key organizer, basically, where it's like a Swiss Army knife of bypass tools. You want to go to the next slide, Tim? Sure. Yep. And this is so weird doing these presentations where we aren't in person and having to go back and forth online, so it takes a bit of adjustment. Adding on to the covert part, this is a really cool thing from Billy Boatwright, social operator. This is something that he gave Tim and I a few DEF CONs ago. I thought it was super cool. Simple pen with, you can see the pick and the tensioner, which has been straightened out, just simply attached inside of the pen. It's very inconspicuous. I added a few rounds of gaffer tape on it, and I'll get into a bit more explanation on why I love gaffer tape.
So you don't always have to have like a laptop bag full of, gear. We see some of these guys will have like a big old backpack for their red team engagement full of different tools that you're not going to use. Something light, I think, is advisable. This is one of the light covert kits that Brett and I both, use. This is actually Brent's stuff in the hotel that he kind of scattered around on the bed there. But having something like the GPD Pocket laptop, I know a lot of people used to use like that Pwn tablet, the Nexus tablet with NetHunter on it and things like that. But the GPD is, it's a pretty powerful laptop for the size of it. And it's really handy, especially when doing like wireless security assessments in addition to, and it kind of gives you an option to install a lot of tools that you weren't able to install on maybe a Nexus or something. For example, being able to flash your proxy on the fly or your prox mark on the fly using that laptop, a lot of other things too. Having a logbook is always important. So when you get into the facility, I know sometimes your adrenaline's going. If any of you guys have ever done any kind of tests like this, I'm sure you'll agree with me. But one of the first things I do is go straight to the bathroom. When I go to the bathroom, I recompose myself, and using that logbook to make sure that I'm recording, not as I go, because of course that's conspicuous, but just kind of taking note of key moments. So I gained access to this area at this time, or something like that. That way, if the client wants to, they can go back and they can see if their camera coverage. So if you're not trying to avoid camera coverage, they can go back and they can confirm what happened, or look at the badge swipes and see, when a badge that you compromised was utilized and where, or something like that. So it's always handy for the client. I mentioned, kind of recomposing yourself. That's what that candy bar is there for. Brent started doing this a long time ago. He would carry that Milky Way on him, and then just to kind of get that your everything regulated and chilled out, because a lot of times, again, when your adrenaline's going, you're sweating and your heart's racing, and you find yourself in this moment of where your stressors are exacerbated. So that kind of helps you to relax a little bit. A lot of these other things on here you've probably seen, having a fake badge, USB devices, having something like a keylogger. And this, I think that's a rubber ducky, but having like a bash, any of the Hack 5 gadgets, like a land turtle, pineapple nano, the lock picks, and then of course latch slipping, which we'll get into in a moment. But those are a few of our favorite tools there. Oh, and you may ask, why are there cigarettes on there? Well, smoke breaks are still a thing. It may not always be cigarettes, it may be people vaping outside, but it happens, and there's been several times where we've taken advantage of that to either try to clone a badge, to just drive by, ask for directions, pretending we're lost, and then taking a picture or getting a good look at their badge, going back, duplicating that badge, and then coming back a couple of days later to getting access to the building. And that's just a closer look at that GPD micro laptop.
So, we talked about picking locks, and sometimes you don't even need to do that. You don't even need to worry about the lock because it's not set properly. Or the lock, the keyway is fine, I'm sorry, but the latch is not set properly in the doorway. So as you can see here, this is my favorite attack. This has got me in more places than anything else. You can see how fast that attack is. So after one of the most secure places that I've been tasked to do an assessment against, the culture there was very security aware. They actually did things very well. One person would badge in, they would enter the door and turn around and close it and make sure it was closed before the next person badged in. That's not convenient, but it's ideal. Security is not always convenient, but in this particular case, I stood in the hallway right outside of the elevator, waiting to go in the door. And it took me about 15 to 20 minutes. And I was actually on the phone with my wife the whole time, making myself appear busy so that someone was to be less likely to come and challenge me. So after a while, I saw the person walk in. I was watching people's body language. You could tell who was focused, who was paying attention. And then I was waiting for someone that seemed more shy, more less likely to question it if I were to tailgate, someone that just really didn't want to be bothered. So after about 15, 20 minutes, that person came along. As they badged in, they started to walk away and weren't paying attention to the door. And so I was able to grab it and then quickly walk in. From there, one of my favorite things to do is look for an open or guest cubicle. That's where I will sit down and unplug the phone line or plug directly into the network jack and begin the network assessment, trying to send shells out to the red team or whatever the task is. After about 2 hours of doing this, I'd gotten what I needed to do for the red team. So I got up and started walking around. Wasn't really familiar with the floors in this particular place, but it was one of those moments where it was such a freebie that it's hilarious. I was walking by, and on the door I noticed a sign that says secret comms room. There's a black sign that said secret comms room. I was like, oh, that's cool. So the door was locked. I was able to slip that latch and go right in. Nobody was in there. You could see all of these blank cat cards that they would make for users. Inside of that room in the back was a red sign that said top secret comms room. Tim, if you go back to the previous slide, you can see this Kaba style lock. It's a very, very secure lock. It's a great lock. They also had biometric fingerprint reader with card and PIN number. So, I mean, this door, they've spent a lot of money on it, but what they failed to do was set the latch properly. So I was able to slip that latch with a simple piece of plastic. This next slide, too, is a very similar attack with a shove knife.
Yeah, so I'm outside here, and what's funny about this too is that this particular client, they had a PTZ camera outside. It's all scratched up on the dome, and come to find out later on when we were looking at their security system, they couldn't see anything because of the weather worn thing. So make sure that you're maintaining this kind of stuff. And then also for the just a note, for the sake of time, we may be flying through some of these slides. So fortunately, this is being recorded, so you'll be able to go back and look at it and push pause at your leisure.
Yeah, so here I am. This is after the attack. We're just doing a quick recording for the client, which, thankfully to them, they allowed us to share this. So it's another thing. Get approval from clients before you start sharing videos and stuff like this and talks. You can see the latch there. Quickly see that shove knife go in between there and pop it open. Super quick.
Fancy man bun there.
And just to add to that too, Shrum tool, these are also great for latch slipping. They sort of give you a bit more oomph whenever you need to retract the latch. They're great tools. There's a few different sizes. I recommend having both sizes for different variations. If you've done these physical assessments before, you're aware of what I'm talking about. Here's another version. So this is, you can see in front of the where the latch is, you can see the latch guard, the latch guard there. So basically, that's trying to block the attack from the piece of plastic. So with this tool, I'm basically just bypassing that latch guard altogether and going straight over top of it, slipping the latch and opening the door. Tim, will you play that one more time, please? It's so quick that that's one of the reasons it's great. So here we are going over the latch guard. There we go. Super easy.
Or you could just use a coat hanger.
Yep. We'll do the same thing. It'll take a bit more work. You have to finesse it a little bit. It's not as simple, but it will work. And we talked about the latch not being set properly. So the security pin needs to be pressed. If the security pin and the latch are both going inside the strike plate, then that means the security pin is not set. So make sure whoever is installing these locks, whether it's maintenance or a locksmith, make sure they know what they're doing. Otherwise, it doesn't matter if you have a $10 lock or a $300 lock.
Okay, so this is the under the door tool. You've probably heard of it, but in this video, I'm using it at my hotel. A lot of people may not consider this, but all hotels are pretty much vulnerable to this, and a lot of buildings that we do assessments for. So the tool just goes under the door, you grab the latch, and then you're just able to open it from the other side, bypassing any kind of access control. A way to prevent this simply is by rolling up a piece like a towel or something like that and shoving it in there. There's other things you can get to that are, of course, not like a towel, but if you're staying at a hotel and you just want to, if you're paranoid, it's a handy tip. So this is a thumb turner tool. You can just slide it. If there's a big enough gap, you can slide it in there and you just turn the handle and it just turns that knob from the inside, essentially doing the similar thing as the under the door tool, and then also this tool that Brent will be demonstrating in the crash bar tool on the next slide.
Yeah, so as you can see the physical gap between the doors. Through the glass, you can see the crash bar. So basically, I just take this, I insert it into the gap, I turn it in a way where it's going to press in on the crash bar just as if you were on the other side trying to exit. And obviously a quick way to mitigate that is to close that physical gap with an astragal, a security astragal, one that can't be manipulated easily. So or you can make your own. This is one that I made from some wire that you can find pretty easily in campaign signs, and basically just bend it in a way. And I put some heat shrink on the ends to prevent scratching. It's a lot smaller profile than the one that you saw in the previous video, and it's just as successful.
So request active sensors, you've probably seen some of our videos floating around like Twitter or YouTube. But we often bypass this with canned air. There's a few different ways you can do this. A lot of these sensors are based off of both motion and temperature. So that temperature fluctuation can go, cold or hot. It doesn't necessarily have to be like a heat sensor. And what happens is a lot of times people will place these way too close to the door. If you look at that top, or if it's improperly configured, and you're able to trip that with some kind of motion, then you can open the door from the outside. And that's exactly what we do here. At the beginning here, you'll see Brent is doing something prior to us bypassing this request for access sensor, just to kind of keep access. So let me push play here.
Yeah, so this is just a really quick, like, hey, let me grab these items off my desk so that we can keep going in and out. Obviously, this is not ideal. As you can see, it's pretty sloppy, but it works. It weakens the mag lock enough where, so wait a few seconds here, the door has reset, it's locked. Just come over and pull it open as though it's not locked at all.
So what this does is if you've got any kind of monitoring system, it will still show that door is shut. It won't show that it's ajar. So, sticking something like that will keep the door open. Instead, it's still got that connectivity to at least trick the sensor into believing that it is shut. And here is the canned air trick I was talking about. So show that the door is locked, use the canned air, and the bitterments from that canned air, when you turn it upside down, will raise, and then it just tricks that sensor. This, we point out that there is a two-factor authentication. So there's a fingerprint reader and then a badge reader as well. The door is locked. Pro tip, carry 2 straws with you. Don't always just carry one. So in this, the straw did pop off, and then I go and I do it again as Brent's recording me. But yeah, again, those bitterments, it turns cold. Also, watch your hands. You can get a chemical burn if you're not careful when using compressed air like that. So when you do turn it down, it does get very cold. And so just be mindful of that.
Yeah, and don't try it too much, especially in a confined office space, because it will linger and everyone will have this awful taste in their mouth. This is a similar attack. We can just show this real quick, but basically that is a hand warmer going through, tripping the request for exit sensor on the other side. As Tim mentioned, you've got your 2 factors, your motion and your temperature variance. Same thing here. And then, as I mentioned earlier, all those attacks that where we put anything through the door, a security astrogol is a super quick, easy way to fix that.
So Brent showed in that video earlier, another way you can do that. Brent mentioned gaffer tape earlier too. Gaffer tape, if you just put a couple layers on there, it's just as effective and it blends in a lot more than using a paperclip.
Yeah, so for door checks, the paperclip makes it way too weak, so security guard or whoever is going to know, okay, this door is clearly not locked. The gaffer tape requires a pretty good pull on it to open it.
So the number one way we get into these buildings isn't by bypassing stuff or anything like that. It's simply by tailgating and pretending we're supposed to be there. So, tailgating is still it's still like one of the number one attack vectors, I think, for covert entry.
Yeah, people are super nice. So we're going to actually be releasing a video on this. We're painting pin pads and picking up on people's pin numbers. And so we can go past that because I know we're getting low on time.
We mentioned some key-to-like systems. These are some common keys that you can use to get access to control panels, cabinet keys, a lot of different things like that. Our buddy Deviant Olem has a pretty comprehensive list of these keys. It's pretty awesome. So that's a few. Service elevators, they're amazing. Oftentimes they don't, if there's a badge restricted access for an elevator in a lobby or something, try to get to the back and look for a service elevator. Oftentimes they do not have badge access and it's less populated. So shimming.
That's Tim shimming. Go ahead, Tim. Sorry about that.
Oh, no worries. So, a lot of combination locks, for example, people are like, how do you get past combination locks? Same thing. Using a shim, you can make shims yourself or you can buy them. A lot of lockpick vendors sell them. Just sliding it in there. I use it on both.
Yeah, there's a lot of videos too where you can make these out of by cutting aluminum cans.
Yep. So pretty quick, pretty easy. A lot of those master locks that are shown there are super easy to bypass, either by shimming or like a quick stick or just simply picking some.
All of these locks that you see there are the locks that we give to people when we're teaching them how to pick locks, if that tells you anything. So fix it with a better lock.
This is just a bonus real quick. There's something called a rogue ring. I'm using one hand just because I was recording it, but it's got a shim in it. Same principle. When will you do this? Probably not going to do it when you're on a client side if you get arrested or something like that. But it is a handy skill to know. Criminals do know this. And you can get this ring. There's a lot of different versions of this ring, but I believe Scam School has a pretty cool version. You just slide it in between the teeth, bypass that double lock, and then get free of the handcuffs.
Yep, hinge pin removal. If you see an external door with the hinge pins that are externally facing, and you're going to be risky, just take it off the hinges.
Yep. No tech badge emulation. Again, we mentioned you can just kind of forge a badge. There's a lot of different things out there. Here's a few of the common low frequency and high frequency badges, badge readers. Utilizing something like the Proxmark, the new Proxmark RDV4 there on the right, on the left. Those are the two that Brent and I have been using for years, either the Proxmark Easy or just the regular old Proxmark with the battery in it. But easily concealable.
They're great. You can hide these things anywhere. Clipboard. Tim, I think there's a video. Yep, there it is, right there.
So in this video, there's actually an Arduino. I've got the Proxmark in there too, but there's an Arduino that is running, and it's got a NIC on it that you can connect to, so that someone can actively see badges that you steal, and outside of just doing the replay attacks.
Nice. Yeah, we hide these in all sorts of things. Prime example.
Which I wish
more stories on that we were unfortunately out of time to share. We do have that on a few other talks inside of the badge cloner. A NIC on that as well. This is another video of a cloned badge being replayed. Tim, this was one you cloned off of a security guard, wasn't it?
Yeah, I was talking to the security guard, and I literally bumped his chest with my hand, and he didn't even notice on that.
Their devices, you can place bugs, basically tap the head reader and access that. You can see it here.
We recommend the ESP key. It's pretty awesome. It has a Wi-Fi enabled, so you're able to replay attacks and stuff or badge swipes and things from your phone. It's pretty neat.
Yeah, USB attacks. That's pretty well-known thing, so we won't get into that too much, again, because of time constraints, unfortunately. But if you have things that are wide open like this, where anybody can just walk in and plug in something, that's obviously super bad. There's several USB-based tools, such as what's listed here.
Yeah, a lot of times I'll use the keylogger and just say that I'm doing a network or a network test, speed test, or something like that, and have people, hey, can you lock your system? Then I'll plug it in, be like, hey, can I get you to log back in real quick? And then bam, you've got their domain credentials.
Yep. So let's. I think we're pretty much out of time at this point. I know we've got a few things we've sort of mentioned pretty quick. So yeah, just common things to look for: shredder bins, unlocked machines, ways to basically help us get in. And so these are all obviously quick things to look for.
Social engineering, make sure that things you can do, clean desktop policy, I mentioned that, lock your stuff, have minimum baseline configurations. Make sure you're not just doing a security awareness training every year, but it's a security culture, and make sure it's ingrained in your people. It shouldn't just be like, oh, okay, well, I did my online test and quiz, so I scored a 80%. I'm good to go for the rest of the year. It doesn't matter how great your electronic access controls are or your physical access controls, if you can just walk in or if it's placed in something that's with a poor locking core or something like that.
Yep, that's sorry we had to sort of speed through the end there.
Hey guys, welcome to join our talk. Today, we'll be demonstrating our engine, Quark. It is an obfuscation neglect Android malware scoring system. So my name is Kunyu Chen. I'm a security researcher and a founder of Quark Engine. And we also have another speaker, Jingwei Song. He's the co-founder of Quark Engine, and he gave talks in security conferences like HITB and DEF CON. So this is the outline. Number 1, we will introduce our malware scoring system. And number 2, we will show you how we design the Delvik bytecode loader. And number 3, we will go through 2 cases of real malware analysis using Quark Engine. And number 4, we will share our strategy of generating the detection rules. And the last thing, yes, the future works. We still have a lot of things to do. Alright, so let's introduce the malware scoring system. As we know, when developing a malware analysis engine, it is important to have a scoring system. However, those systems are either business secrets or too complicated. Therefore, we decided to create a simple but solid one and take that as a challenge. And since we wanted to design a novel scoring system, we stopped reading and decoding what other people do in the field of cybersecurity because we don't want our ideas to be subjected to the existing systems. So we start to find ideas in field other than cybersecurity, and luckily we found one. Yes, the best practice we found is the criminal law. So when sentenced the penalty for the criminal, the judge weighs the penalty based on the criminal law, and after decoding the law, we find principles behind it. And we develop a scoring system for Android malware. There are only 8 principles decoded from the criminal law, and I'll go through it in the following slides. Now let's see principle number 1. A malware crime consists of action and targets. In the criminal law, the definition of a crime consists of action and targets. For example, steal money and kill people. So with this principle in mind, we developed the definition of a crime for Android malware. And the definition is, the malware crime consists of action and targets. For example, steal photos or steal your banking account passwords. Now let's see principle number 2. We consider that the loss of fame is greater than the loss of wealth. In the criminal law, physical body injury is more serious than psychological injury. So the principle we decoded here is, when things are hard to recover, we consider it a felony. With this principle decoded, we develop our second principle. We consider the loss of fame is greater than the loss of wealth because it's easier to make money back than rebuild your reputation. Okay, now let's see principle number 3, arithmetic sequence. In the criminal law, when a murderer is sentenced 20 years in prison, and a robber is sentenced 7 years in prison for his crime. Why 20 and 7 years? Why the number? We found no obvious principles in the criminal law, so we use arithmetic sequence to weight the penalty of each crime. For example, the penalty weight of Y1 is 10, Y2 20, and Y3 30, etc. So now let's see the most important part of the scoring system. We create an author theory which consists of 3 principles. Now, principle number 4, 5, and number 6. Let's first look at principle number 4. The later the stage, the more we're sure that a crime is practiced. As mentioned in Chapter 4 of Taiwan Criminal Law, each crime consists of a sequence of behaviors. Those behaviors can be categorized in the specific order. Let's take murder for example. In stage 1, determine, it means somebody decided to kill someone. In stage 2, conspiracy, it means he or she started to make a plan for the murder. And in stage 3, preparation, it means buying stuffs, for example, weapons, or arranging services for the murder plan. And in stage 4, start, it means when things are all set, the murderer takes action and is on the way to kill someone. In stage 5, practice, it means the murderer does pull the trigger and shoot someone. So as we can see here, the later the stage, the more we are sure that the crime is practiced. So with this principle in mind, we developed Android malware crime author theory. And in this theory, we also have 5 stages for the crime. For example, if a malware tries to send out your location data by using SMS, in stage 1, we will check if related permission is requested by the malware. And then we will check if the key native APIs is called. And in stage 3, we will see if certain combination of native API exists. And then we will check if the APIs are called in a specific order. Finally, we check if the APIs are handling the same register. Okay, so now you can see from this picture, this is a 2-dimensional map for Android malware crime. For the crimes, we put them in y-axis. And for each crime, we use x-axis to see the evidence we caught for this crime. So, x5, y1, it means in crime number 1, we have found native APIs that are called in the correct sequence and they're handling the same register. And x3, y5 means in crime number 5, we have found certain combination of native APIs that is used in this APK. So now let's look at principle number 5. The more evidence we caught, the more penalty weight we give. So we give stage 2 more weights than stage 1, and stage 3 more weights than stage 2, etc. Okay, principle number 6. Proportional sequence. As we decode it from the criminal law, the later the stage, the more we are sure that the crime is practiced. So we consider proportional sequence, for example, 2 to the power of n, to present such principle in our scoring system. Alright, principle number 7. Crimes are independent events. For simplicity, we assume crimes are independent events and penalty weights can be added up directly. So this is an example of adding up 2 crimes. In the malware, we find 2 crimes. You're stealing photos and stealing your banking account password. So the calculation of the total penalty weight is quite simple. For each crime, we use penalty weight of crime to multiply proportion of caught evidence and add up the result of the 2. The last principle, principle number 8, threshold generate system. After calculating the total penalty weight for the malware, we need to have threat level threshold so that we can tell which threat level does the malware fit in. Unfortunately, we can't find them in the criminal law. But we know we need to design a threshold generate system for that, not just give any number by intuition. So we decided that threshold for each level is the sum of the same proportion called evidence multiplies penalty weight of crimes. Yeah, we know. It's not a perfect one, but we're sure that we build a foundation for future optimization. All right, now, let's talk about the design logic of Delphic bytecode loader. And Junwei, he will take care of this part.
Hello everyone, my name is Junwei, and I will take care of this part. Our Delphi bytecode loader is actually the implementation of the Android malware crime order theory. We implement every stage of the theory. There are 5 stages. The first 3 stages are easy. We simply use APIs in another open source tool, AndroidGuard, to implement the first 3 stages. As I just mentioned, the implementation of the first 3 stages are easy. But in stage 4, we need to do a little bit more. So before the implementation, we need to know what does stage 4 do. In stage 4, we find the calling sequence of the native APIs and check if they are called in a specific order. For example, if a malware sends out your location data by SNS, then first it will call native API getCellLocation to get your location data, and then call native API sendTextMessage to send your location data by SNS. Normally, native API are wrapped in functions, so we trace back to see which function is cross-referenced from the native API. And we call those functions the parent function. And we will keep tracing back until we find the mutual parent function for both native APIs. Here is the example. sendTextMessage is called by sendSNS, which is the parent function of sendTextMessage. And getCellLocation is called by getLocation, which is the parent function of getCellLocation. And if we keep tracing back, we will see that both sendSNS and getLocation shares the same parent function, sendMessage. And after we find the mutual parent function, we will scan through a small line code of the mutual parent function and check which function is called first. So this is the small line code of sendMessage. We can see that getLocation is called first to get location data of the cell phone, and the sendSNS is called to send out the location data. And in stage 4, we found out that our design can also overcome the obfuscation techniques used by the malware. When applying obfuscation techniques, function except native API are renamed. This has made the decompiled source code hard to read for human. But machine can still run the code because the logic of the code remains the same. Here is the example. When applying obfuscation techniques, native API sendTextMessage is called by function K, and function K is called by function F. The alternative API, getCellLocation, is called by function E, and both function E and F shares the same parent function, A. You see, if you start reading the decompiled source code of A, it will be hard to figure out what is going on there. And by the way, since our goal is to find the mutual parent function, so it doesn't matter how many layers the wrappers are. Now, let's see the implementation of stage 5. Yes, the most important part. In stage 5, we need to confirm that if the native API are handling the send register. Let's use the send example. Send out your location data by using SNS. So when native API getCellLocation is called, it will return the location data of the cell phone. And what we do in stage 5 is to check if the alternative API send text messaging sends out the location data returned from getCellLocation. So in stage 5, we simulate the CPU operation. We read line by line of the multi-line source code and operate like CPU to get two things. Number one, the value of every register. Number two, the information like functions who have operated the send register. To make this happen, we create a self-defined data type. We call it register object. In each register object, we store three kinds of information. Number one, the register name. Number two, the value of the register. And number three, the function who uses this register. Let's see the example. So the register name is V7, and the value of the register is a string. And the string appends the value of string 1 and the result of function 1. And then we can see that the register is used as the input resource of the function 2. And by the way, when viewing the value of used by which function in a register object, we expand every register by cross-referencing other register object in the table. So, for example, by cross-referencing, we know that V8 is a string called user location, and V3 is a function called getLocation. As you can see in the lower right corner, the result of getLocation is append to the string user location, and the new string is sent out by using function send SNS. In other words, the value of register V7 is generated by using function getLocation, which has native API 1 in it, and the value is used as the input for function send SNS, which has native API 2 in it. So now, we prove that by using the register objects, we can check if the APIs are handling the send register. So after we scan through the source code, we produce lots of register objects. And those register objects will be organized with a two-dimensional Python list. It is a similar idea like hash table. We use it to boost out the read and write of the list. So now, let's see the table. As you can see here, register V4 has 3 register objects. That means in the source code we scan, V4 was used 3 times, and every time when it was used, we store the present value of the register and the function who used it if there is one. So basically, the whole table is the history of registers. So, when we finish constructing the table, we then scan through all register objects in the table to check if the native API are handling the same register. So now, let's see how to use Quark Engine to analyze the malware. Now, let's get back to Kunyu.
In this section, we prepare two malware. One is non-obfuscated and the other one is obfuscated. And for each malware, we will show how we detect the behavior of the malware with the detection rule. Now let's look at the first malware. This is a non-obfuscated one. And we will use the rules in Quark Engine to detect whether if the malware sent out cell phone location data by using SMS. So this is the detailed report of Quark Engine. In this report, the engine shows the detection results of one single malware behavior, or you can say one single malware crime. So for example, we try to find if the malware sent out your location data by using SMS. In this report, we list out the evidence we found in each stage of the Android malware crime order theory, and the report shows we find evidence in every stage, which means we have 100% of confidence that the malware has this behavior. So let's see, in stage 1, permissions like send SMS, access core locations, and find locations are requested. In the second stage, key native APIs like get cell location and send text messages are used. And in stage 3, we find certain combinations of native API exist. And in stage 4, we found out that the function like send message and do byte, the APIs are called in the right sequence. And in stage 5, in function send message, we found out that those APIs are handling the same register. So now let's think, if you're analyzing this malware and you want to trace the compiled source code to see the evidence, how do you do it? Our suggestion is you start reading the report backwards. That means you start from stage 5. For example, in stage 5, we know that inside the function of send message, it has two functions that contains the two native APIs respectively, and they're handling the same register. So you start to locate function send message in the decompiled source code. And in stage 4, we know that those two functions are called in the right sequence. So we can start to find functions that contains the native APIs and check if they're really called in the right sequence. The information of the two functions and the sequence will be shown in the next version of Quark Engine. Recently, we have developed a new feature, a call graph for high potential malicious activity. I call it the Google Map for malware analysis. Now let's see. On top of the graph, we start our journey from the mutual function. And then, according to the map, we can see it clearly that which function wrapped the native APIs. And calling sequence of these functions. Amazing, isn't it? So now let's start the journey. Let's locate send message, the mutual parent function of the key native APIs. As we can see in this map, it first calls function get location, and then it calls function send SMS. And in function get location, it calls native API get cell location. Let's see the other wrapped function, send SMS. In this function, it calls native API send text message. So now we have the roadmap. Let's read the source code. All right, let's locate the function send message. And we found out that two functions that contains the two native APIs respectively. There are send SMS and get location. And if we dive in the source code of function get location, we will see that it contains native API get cell location. And if we dive into the source code of function send SMS, we will see that it contains native API send text message. So the code here means it first collects your cell phone location data and send it out through SMS. So now let's dive into the source code of get cell location. As you can see in the source code, it tries to call native API get cell location and return this information at the end of the code. And now let's dive into the source code of send SMS. Native API send text message is used to send out the location information. Quite simple, isn't it? Now let's look at the second malware. This is an obfuscated one. We will use the rule in Quark Engine to find whether if the malware detects Wi-Fi hotspot by gathering information like active network info and cell phone location. Okay, so as a malware analyst, we read the report backwards. As you can see, in stage 5 there are functions like p.a, attribute.c, and af.run. And those functions has two functions that contains the native API respectively. And they're handling the same register. And in stage 4, those two functions are also called in the right sequence in functions like p.a, attribute.c, and af.run. So, according to the report, we can say that the malware has the behavior of Wi-Fi hotspot detection in 3 parts of the source code, and we can pick any part for further analysis. So we pick function p.a. Again, let's start the journey. Let's choose parent function p.a. As we can see in the map, it first calls function ap.a, and then it calls function f.f. And in function ap.a, it calls native API get active network info. Let's see the other wrapped function f.f. In this function, it calls native API get cell location. So now we know that the roadmap. Now we know the roadmap to trace the code. All right, let's look at the source code. Now let's first locate function p.a. And we found out that two functions that contains the two native APIs respectively. They are ap.a and f.f. And if we dive into the source code of function of ap.a, we will see that it contains native API get active network info. And if we dive into the source code of function f.f, we will see that it contains native API get cell location. So the code here means after collecting information from function ap.a and f.f, they send information as an input for function am.a. So now let's dive into the source code of function ap.a. As you can see in the source code, it tries to call native API get active network info and return the related information at some point. And now let's dive into the source code of function f.f. Native API get cell location is used to get the cell phone location data, and this information is processed with some other strings. At the end of this function, it returns the string with information. As I mentioned earlier, after collecting information from function ap.a and f.f, they use the information as an input for function am.a. And we noticed one thing. The function am.a used byte array output string as one of its input parameters. And we know when saying byte array output string, it means that the function is probably trying to write the data into a file. This is amazing, isn't it? So with Qwak Engine, malware analysis can really boost up their productivity. Are you curious about more features of Qwak Engine? This time, we also present our Qwak Engine at GrayHat Armory. In Armory's talk, more features will be introduced. We will demonstrate how to use Qwak Engine to analyze OMID's Android RAT, providing that the engine is useful, practical, and is easy to use. The full report shows how malware analysts can use Qwak Engine to boost up their analysis and to quickly tell a good story behind the malware. So don't forget to take a look. By the way, if you can't wait to read the PDF report, we put it in the link below. Please enjoy. Okay, so now I will introduce our detection rule generate strategy. So why do we need to develop the detection rule generate strategy? Because to make our engine practical and easy to use, we need to have more detection rules. However, the speed of rule generated by human is quite slow, and a human-generated rule is subjected to his or her experiences of malware analysis. So we develop a rule strategy. So we develop a rule generate strategy to boost up the production of detection rules. And since our goal is to find all kinds of the behaviors in the malware, so if we use permissions and native APIs to generate all possible rules, we will have an amazing amount of rules. After generating the rules, we then use Qwak Engine to find the intersection between those amazing amounts of rules and the malware which we prepared. In other words, we find rules that match the malware's behaviors. However, this is not a good way to generate detection rules, because it's time and resource consuming. So we developed a 7-step rule generate strategy. Step 1, we crawl down all native API information on Android official API reference. For example, this is the native API information of send text message. You can see the input parameters, return value, and the description of this API. Okay, step 2. We did a little bit modification to our engine. We ignored the permission checks in stage 1 of the Android malware crime author theory. And in step 3, we find all kinds of API combination and generate rules without permission information. And in stage 4, we use the modified Qwak Engine to find the intersection of the rules and the malwares. We call rules in the intersection the first stage verified rules. In other words, these rules need to be verified again. And since we don't need to generate rules with permission and verify the permissions in Qwak Engine, the whole process of rule production speeds up. In stage 5, we try to generate rules with permissions. Inside the intersection, we have first stage verified rules matched with malwares. We then use the first stage rules and permissions in the matched malware to generate rules with permission, which is the second stage rules. And in stage 6, we then use Qwak Engine, the full function version, to find again the intersection of the second stage rules, which are the one with permission and the malware we prepared. After that, for each rule, we label the number of matched malware. For example, the behavior of rule number 1 can be found in 100 malware. And in step 7, after labeling the rules, we then sort the rules by the number of masked malware, and then we will review the rules from the highest masked one. All right, the last part, future works. As I mentioned earlier, we still have a lot of things to do. For example, we need to have more detection rules and more bytecode instructions. And we will publish malware analysis report regularly to show what Qwak can do. And we want to have more features of the Delphic bytecode loader, for example, the downloader. And we also would like to apply the scoring system to other binary formats, for example, PE format or ELF formats. And we noticed that API changes in different versions of Android. We will also take care of this problem in the next version of Qwak. Oh, we probably will change the core library since AndroGod is quite inactive recently. One more thing I would like to share. Actually, we made Qwak itself easier to be integrated to other tools. For example, users can now import Qwak as a Python library and output the analysis results as a JSON file. Also, Qwak is collected in Black Arc Linux and is integrated to a threat intelligence analysis tool called Intel-All, and you can just install them and give it a shot. And there is one nugget that I would like to share. We work at the limit of our tools. When new tools come along, new things are possible. Okay, that's all for today. And if you have any question, please feel free to DM our Twitter accounts. Thank you. Sorry.
Welcome back again. This is day 2. Omar, what was your favorite presentation from today?
So today we had a lot of different presentations that I don't consider myself to picking one specifically as my favorite, but I really enjoy Cedric's presentation, Red Team red techniques and blue team considerations in modern tech environments. He actually, had a purple teamish, right? If you wanted to put a color in that, right? A presentation. Felipe Perez, he's actually a colleague from Brazil. He did a really amazing presentation on how to pivot on exploitations using or in Docker environments, so hacking Docker containers. And as a matter of fact, today we had a few things related to Docker and different cloud environments. And yesterday, we actually follow a theme, right? Because Rohit was actually mentioning or introduced a tool called Docker Ent. And then before that, John Helmus was actually talking about AWS. So, I think that cloud and Docker today, and yesterday, they were the number one topics, right? Now, the other presentation that I really enjoyed was Brent White and Tim Roberts on breaking into your building. So they actually shifted gears into how to perform a physical, pen testing, red teaming engagement, right? And basically, they call it a hacker's guide to unauthorized physical access. So again, tons of different awesome presentations in here today. Oh, I forgot about the other Docker presentation. Arsenio Aguirre, he was actually going over offensive Docker or CTF pen testing and bug bounties as well. So really, really a lot of cool presentations here today. And I heard that both CTFs are going very well. Can you comment on those?
Yeah, they're really hard. I'm still trying to go at them. I really love them though.
Very cool. And a quick reminder, of course, continue the conversation in Discord. And, we have an after hours event at the GrayHat Discord server. And there's different channels in there that you can actually participate in this game. So Hacker Jeopardy, the karaoke one, and then Jackbox as well. I think there are 4 of them that are happening as we speak. So thank you and see you tomorrow.
Bye, everyone.